A very good afternoon to one and all again. Thank you for joining us on the afternoon session of our virtual tech day. So we'll start the first session for the afternoon. The first session for the afternoon is a very interesting session. It's on application software development for embedded systems. And to host this, we have a very interesting personality, Mr. Alex Terfloth. Alex Terfloth is a software engineer with around 35 years of experience, and he spent most of his years, the last 16 years primarily in focusing on model-based development. All right. He has worked on many automotive and non-automotive development projects, and he's currently the product owner of ITEMIS Create, which is a tool for model-based development of state machines for embedded systems. Thank you so much, Axel, for joining us. It's a pleasure hosting you. And over to you. Thank you.
Thank you very much. It's a pleasure for me to have the chance to talk about the topic. So I hope that you all can understand me. Is that the case? Hello?
Yeah, Axel, we can hear you. We can hear you.
Yeah, perfect. Good. So thank you for the introduction. So I don't want to add much more to that. So I will have to share my screen. So I will directly jump into the presentation and talk. So one moment. So I'm not so often using Zoom, so I have to orientate a little bit. Use desktop 2, okay. I hope that you can see everything.
Yes, Axel, your screen is visible. Please go
ahead. Okay, my screen is visible. That is perfect. Good. So let's start here. So yes, the topic for today is rapid state machine development and unit testing for embedded systems. And yeah, so what do we see today? Oh, I hear this funny bar. I have to move it away. Okay, so sorry. So first of all, I assume that many of you already know the concept of state charts or state machines. And nevertheless, I will shortly talk about what it is and of course present ITEMIS Create as a tool. So we will do a lot of hands-on or see a lot of stuff hands-on here. And after a short introduction, also using some slides, I will jump into the concrete example. So we'll open the IDE and talk about the different topics. So one of the topics is, of course, modeling, also using multiple state machines, then generating code and building an application and also testing the behavior on the model level. And I will also, that's what I show, I will also talk about a little bit how to test the application on the device and also the generated code on the host machine and so on. The example that I chose is turn signal control. So it's not too complicated. It's about many LEDs, of course, and buttons. It's quite simple, but as I don't want to go into detail of some specific application, I think it's a good example to show how state machines can be used in this case. Okay, good. So then let's continue. So ITEMIS Create is a tool by ITEMIS. It's maybe the one of you have before heard of Yakindu state chart tools. So Yakindu is also a ITEMIS brand, and the tool was renamed from Yakindu state chart tool, which specifically addresses what we mainly do, so modeling state machines, and replace it by ITEMIS Create. So the reason is that in future we will add many more features beyond the state machine modeling. But that is not the topic for today. There are also different other tools for security analysis and traceability and so on. Yes, if you're interested in that, then you can simply contact me and then we can talk about that. So today we will, talk about Yakino Stager tools or ITEMIS Create. And that is a tool which is mainly used in technical domains. So mainly for developing embedded systems of different kinds. So from bare metal implementations on small microcontrollers up to in-vehicle infotainment systems and so on in different domains like automotive, medical. So of course we have a lot of users in the automotive domain. All others are also spread across different industries. So what is ITEMIS Create about? So it's an integrated modeling environment which currently mainly focuses on the concept of state machines and covers everything that is really required to develop something. It's not, so of course you can draw, so it's also a drawing tool in that sense, but it is more about than just documenting concepts and behaviors. It's mainly focused on delivering software and making use or takes advantage of a model-based approach here. So we have editing, of course, we have code generation, we have simulation and testing. There is also a validation of the model and so on. So we will take a look at that step by step. Okay, editing is graphical. So we have a graphical editor with integrated textual editing for all those textual parts. It has IDE-like features like proposals and things like that. No, but many modal dialogues, so everything is directly editable. It isn't based on Eclipse, so we will see that. And what we also moving towards is, so that is not in place yet, but this year we will also provide a version integrated in Visual Studio Code and also as a cloud application. So apart from the editor, the graphical and textual part, there are also features beyond, like refactoring support, smart layout, and so on. Okay, validation. The model is checked and you get error markers. We can simulate, so we will see that afterwards. Everything is integrated into the editor. So simulation comes in different flavors. One part is for the interactive debugging. The other is also for testing. So that is also used in that context. Tests can be written as kind of test scripts. This is just a small example. So we call that SCT unit framework. It mainly applies the ideas of unit testing also to state charts. And those tests can be executed on the model level, so using the interpreter, but also on a code level by generating code from the state chart model. So we create a state machine, but also from the unit tests. Okay, so then also coverage is measured, and of course we have code generation. So apart of from the classical embedded code generators like C and C++, we also support others. So Qt is also, of course, an extension to C++. You have users who use it for Qt development, but there are also non-embedded target languages like Java or C# or TypeScript, and we also provide a Python code generator. Yeah, so that is the models. So this is some kind of cross-target language capability, but of course you can get more specific and say, okay, you want to be more specific to C or C++. We will see that later. Now, okay, good. So integration. So I will talk about that later. So that is what I meant. So we can integrate into C or C++ or other target languages, but I will show that later on. So I will, yeah. So if you will be interested after the talk, then we are very happy to if you just want to try it, yeah, and use the tool, so you can get free trials and evaluations. You can simply request that on our webpage. Yeah? Okay, so that's end of the present of the slides. Yeah? And so let's jump into the tool itself. So I will open ITEMIS Create. So you can download it from our website. So it just requires a simple registration. So just you have to leave your email address, and then you get a download link. And yes, so you can directly start because the trial is included automatically, and which can be prolonged. So let's just start the tool. And so that's how it looks like when you first open it. You get a welcome screen with a lot of different hints towards documentation and so on. So it's obvious that it is based on Eclipse. I'm not sure. So many of you may use Eclipse-based IDEs. Yeah. But even if you do not, so like Qt developers use Qt Creator, of course, it is easy to have a coexistence between ITEMIS Create as a tool, but also and then with Qt Creator, for instance, and it's basically the same for all other IDEs. Yeah. Okay, so then let's create a new project. I will just name it Switch. So we will simply start to create a very simple example. I always start with a switch to explain somehow the, I'll rename this here, also switch. Okay. Okay, so I hope that you can see this a little bit better. So when I create the state chart project, then I directly get a state chart created within that project, and here you see well, the state chart editor as a normal integrated as a normal Eclipse editor. It consists mainly of the graphic, so the canvas where we draw our state charts. Then there is some section, a textual section for declarations. So state charts are self-contained in our concept. So it is a little bit different from the concept that you may know from UML or maybe other tools, where you more define the context or the interface of the state machine on a different level. Here it is directly integrated into the state machine itself. That is on the left-hand side. On the right-hand side, you can see all those elements that you can use. So these are those that you know from UML. So the state machine model that we apply are RL state charts. So it was defined well a long time ago. So we also applied some extensions to that concept, but it's more or less what you also know from UML, because that is so it's based on, so the bases are the common concepts defined by Mr.Axel. And so there are states, there are composite states. You can have hierarchies. You could also have parallel states. So we call it orthogonality, but that is more or less what is mentioned as parallel states or end states, right? Then there are entries of different kinds, so regular entries and histories, and final states, exit notes, choices, synchronizations, and so on. Yeah, so that is also the same. That is also provided by Stateflow, for instance, for MathWorks, but without all that what Simulink brings in. So it's really dedicated for state charts or state machines. So we also have a properties view below. So this also represents what we see above. So you can also edit things in a form. here. So I typically prefer to well, do it graphically. So that's normal. So okay, let's go ahead and say we have an off state and an on state, and we want that I don't want, so we have events. So the state machine consists of obviously of states. So we have two states in a switch. Well, a switch is, or a simple switch at least, is nothing that I would normally model with a state machine. But you could do so, but there is of course an overhead so, compared to a simple Boolean or so. But nevertheless, it is a good example. So we have this entry node. So this shows which will be the first state entered when the state machine becomes active. So this means we will be enter the off state as a first state. And then we want to toggle the switch, right? So I want to define a toggle event. So I say, okay, I want if a toggle event occurs, so we can write events on the transitions, then the on transition should be activated. So what we see here is that there is no toggle event declared yet. So it says, okay, the trigger does not exist. And so I could do it this way. So in this case, now toggle is defined, but my event is not defined. And I will also change this one. Okay, now all errors are gone. I could also simply rename things. So I've got a refactoring. I mentioned that before, and say, okay, toggle should now be, I want to go with switch, for instance, then I simply change it to switch. So as we have some kind of, so the language which is embedded here is, well, the textual part is a formal language basically defined like any other programming language, has a grammar-based definition. And here is an escape for the switch, because switch is a keyword in some underlying language. And so that is that's why it is escaped here. So don't. So if you wonder why there is this symbol, that's the reason. Okay, so then let's go ahead and say I want to run this, and I do not generate any code or so. I just start the simulation in order to check if that is the model is fine. So of course this model, so you don't need this kind for this model, but if you have state machines or state charts with a couple starting with 5 or 6 or 7 states, then things may get more complex, and you need the ability to check the dynamic behavior of the state machine. And that is, so it is good to have a directly integrated simulation capability or testing capability. So that is really for interactive purpose. So here we have now in another perspective. This is a simulation perspective, and we have an overview of the different simulations which are running. And below we have the simulation view where the time is running. And so what we can do here is raise the switch event. So I simply click on switch. You see it here on the right hand side. And so I can toggle between those states, right? So this means this machine is executable. So that also means it is formal enough to generate code. So as soon as something is executable in the simulation or in this debugging context, then it's also we can also generate code. That is no problem then. So okay, let's play around a little bit with that. I want to say, okay, go back whenever we switch. The switch event is raised from the outside, so that is an incoming event. It's also defined here. This is an in event. Then I can also have time triggers, like say, okay, after 3 seconds, I want to that the state machine should go back to the off state, right? So I save the state chart, And now it tells me something changed. Do you want to relaunch the simulation? And say, okay, I relaunch it. And now we have it started again. I do switch and do nothing now. And after 3 seconds, it automatically goes back to the initial offset, right? So time events are supported. So there are different kinds. So we are one-shot events, but there is also which does not make sense here on this transition, but you could also use every and so on. So in general, you can simply press Control Space in order to get the different proposals, including the documentation, which is related to that. So we could have always triggers, on-cycle triggers, after and every, and so on. And yeah, so that's what is possible here. So, okay, after 2 seconds, okay. Good, so let's continue. So we can also define, or a state machine may have, so the behavioral state machine is defined in terms of transitions. But of course, we can do something. So the state machine can also produce side effects. So that is, of course, necessary to control something. And so it is also possible to define variables. Let's go ahead and say, okay, so here also we can use code completion. So you get all those things proposed which are available in this scope. And I want to define a variable called brightness. And this is a simple integer. So you see the declaration is a little bit different from C, but nevertheless it can be translated to C, C++, and all other languages. And here in this configuration, we have a simpler type system, which only consists of Boolean, integer, real, string, and void. And these are meant some kind of mathematical way. So we do not say an integer is a 32-bit or 16-bit integer or something like that. You can, within the generated code, you can specify and define that. And there are also other ways to directly use those C or C++ integer types and all other types available in those languages. But let's go with this one. So we have an integer, and which is initially 0, right? And when we go into the on state, so it should simply be a percentage, right? 0 to 100. And here we can now do entry action. So I say, okay, on entry, I want to set the brightness. Oh, it just should be 2, right? I will refactor that afterwards. 200. So I can also click this one to rearrange size. Okay, go here, refactoring, rename, brightness. Okay, there it is. So when we relaunch the simulation, then we see that in addition to the switch, we have a brightness a value, right? So when I switch, brightness will be changed to 100, and now we go back and see, oh, it's still 100. So that's not what we intended. So what we could also do is then say, okay, also the transition, so we can have entry actions and also exit actions within the states, but we can also have actions on the transition. So these are executed when a transition is taken. And we can also say here brightness equals 0. Okay. Relaunch, switch back, and now it's 0. Okay, good. So now I want to have a light which is switched on and then dims down. And when the brightness is 0, then we go back to the offset. So that is an auto dimming down switch or whatever. So what we could do through that, I simply say, okay, we can have not only normal entry and exit actions within the state. It's also, we could also react to any event within a state as a local reaction. And what I do here is I say, okay, let's go say every 100 milliseconds. I want to reduce the brightness. Brightness by, let's say, 10. Then it dims, or let's say 5. Then it takes 2. It's also fine. Okay, good. So resize it. And now what I do here is I could say, okay, I don't want to, should not be switched off explicitly or based on time here on the transition. We could simply say, I want to have this by checking a variable, right? So I would like, or a condition. So this is, I want to enter or switch to the off state if brightness is 0. So we can define conditions here. So you can use check for equality, greater, smaller. You also have simple calculations here. So it is not intended to write large amounts of code here in the state chart, but it is from time to time necessary to define those expressions and statements in order to define and have a proper state machine. Okay, so then let's go ahead and say relaunch. Okay, so I switched it on, and now it counts down. You see it on the right-hand side. And then it goes back to the off state. So after the state was, so the value was increased to 0, it automatically switches back to the off state. So this already shows a couple of features that you can do, and it also highlights somehow the typical workflow, so that you have this iteration of defining behavior and trying out the behavior. So that can be done iteratively, but that can also be done in a using a unit test. Okay, so then let's but we will do that later. Good. So this is first introduction to the tool. So now I will switch to the to a real project which I want to show you. Okay, so here we are now in the STM Cube IDE. I created a small project, and what we see here is also, well, what I've set up is this device, right? It's a STM32 F1, so blue pill, F03 with simple setup. So we have 3 buttons, we have 3 LEDs for the right hand side and 3 LEDs for the left hand side, and I can simply interact with it just by starting a hazard light or blinking left or blinking right. So this is simple. Okay, good. So then let's take a look at the at what we have defined here, or what I have prepared. So we have a regular layout of such a normal STM Cube IDE project. I added a folder called model, and this folder includes everything that is related to the to the application. And we see that we not only have a single state machine, but we have multiple state machines. It's also possible to define or use multiple state machines or define applications consisting of sub-machines and connected state machines and so on. And we have also a small test, but let's first take a look at all those state machines. So the main state machine is a signal control. It's a little bit more complex than that that we have already seen before. Okay, so that's one. Then we have a state machine for flashing the lights. We have a state machine for blinking. This is this animated blink for the for this LED array or the LED arrays. So it's also implemented as a state machine. So I do everything with a state machine, even though you may decide in a project to do things different. Yeah? I just want to highlight how those mechanisms work. And we have a state machine which cares about debalancing the buttons. Yeah? So the switch buttons on the machine. So, so to get an overview, so now we have just a lot of graphical models and code and so on. Just to give an overview on how that is assembled. We have our device here below, and we have different components. So of course there is more software components than shown here, but we have the signal control state machine, and the signal control state machine makes use of 3 sub-machines. So one is the flash for the hazard lights, right? So this mode, so that is flashing. Then we have blinking, blink right, blink left. So that means when I blink to one direction, it's the one, and when I blink to the other direction, it's the other. So all both covered by old state machine. And then we have another state machine, which I mentioned. It is about the buttons. So the buttons state machine cares about receiving or driving the GPIO or reading the GPIOs for the buttons and debouncing the signal, and then forwarding that to the signal control. And then there is some manual code which cares about toggling the LED. So we will see that we do not access the hardware abstraction layer generated from the IDE directly. So we do that indirectly and add some manual code for interfacing that. On the other side, the buttons state machine directly accesses the hardware abstraction layer. So we will see that. And then there is another instance or object called timer service. So we use a lot of time events, and that is used by all state machines basically. Yeah? So it serves time events for state machines and, well, maps that or is driven by a hardware timer basically, which is scheduled for every 10 milliseconds. Okay, good. So then let's take a look. We will to the signal control. How does that work? I will just increase the zoom factor a little bit. Oops. So I hope that you can read everything. So as I said, we have different. So we have, yeah. We'll just remove this for now. We have this 3 main states. One is the idle state, so that where nothing happens. Then we have this hazard light state, and we have the blink state. So within the hazard light states, we refer to the flash submachine. So we can. This is the state machine which is defined here. So this is really simple, comparable to the light switch that we have done before. So we have some configuration, so that can be parameterized or calibrated. So it's a time for the light phase, for the dark phase, And then we have some operation callbacks used by the state machine here. And yeah, so on entry, LEDs are switched on or switched off. And on the other side, when the state machine is deactivated, it makes sure that everything will be switched off. So you can also define exit behavior on the state machine level. Yeah? So that can be done simply on the right-hand side. Good. So this state machine is integrated here. And we simply say, okay, please use flash here as a submachine. And how is that defined? So where is flash defined? It is defined here. So we use variable definitions for state machine types. So when I define this kind of state machine, I do not only have those types that we have seen before, but we also have access to all those state machines which are included here on the top. So we have here, it's called import, but it's basically an include. And this is how that we say, okay, I want to use Blink state machine and the flash state machine. You can also jump to it. Where is it? There. We can then go back. Yeah, so that's quite easy. Then we have different. So these are simply defined as variables, and then within the state, within the definition, we can interact with those submachines. So for the left part, we integrate the Blink left, and for the right part, the Blink right state machine. So we could also do other things like say, okay, Blink right dot, and here we see all those interface elements which are available from a state machine. Like you can exit a state machine, so deactivate it, or enter activate it. You can ask if it's active or not, if it's final, and so on. You can access all those things defined by the state machine. So, okay, so that's how the hierarchy is, the state machine hierarchy is set up. Good, so that is this part. And so what we do now is, so I will simply show the this information. So this is, so the device is currently not coupled to the simulation here, so that is also possible, but that I've not set that up for now. So we will just take a look at the application. So now I will do some blinking, and now I see that direction lights or signal turn signals are blinking. And normally I want that I want to switch to the hazard lights, right? Directly. So when I'm in blinking state and I press the middle button, so this is for the hazard switch or the hazard lights, then it should directly switch to the flashing mode, so to the hazard mode. And that is not happening. So that means that we have to add functionality to the model. So, and that is not happening because we have no, when we take a look here, we have no transition from blink to hazard lights. So there is just a transition out of blink state, which is a stop blinking, and it goes to idle, but we have no direct direction to the hazard state. So what I want to do here is I want to define a new there it is, a new unit test class. So I will simply call it hazard test. So this is our test case description language. So it's textual, it is not graphical, and it works like, so it's somehow a test script. And if you know unit testing, then you will find many commonalities to code unit testing. The difference is basically that we use this here on a model level. So the unit test is directly aware of the state machine. And here I don't want to test the blink state machine. I want to test the signal control, right? And so we have a test method, and I say, okay, I want to test that hazard mode must be from blink. Okay, so we say this is an operation. So we could also define operation which are no test cases, but all annotated with this annotation are evaluated as test cases. Now I can simply run this as a unit test, and then we will see. Okay, we'll save it. That it is successful because it cannot fail. Yeah? So what we do here is we enter the state machine, so that means it is activated, and that so we have an implicit instance. So we say we have a test class for signal control, and so there is implicitly an instance of signal control, and we have to activate that. Yeah? So that's the very first step. Normally, I prefer to use things like given, and it's such a kind of pattern for describing test cases. Okay, so when we have a active state machine, and we have that right. Yeah. Okay. So we require a parameter. So we have two blinking modes. One is comfort blinking, which automatically switches off after 3 cycles. The other is a continuous blinking. And if we pass a payload, so Boolean value true, then it will be comfort blinking. But I want to go with a continuous blink. So I say, okay, I raise the right. So right, and say then, okay, I assert that the state blink is active. So to be more concrete, we should be in the right state. So that is what we expect. And so when we do then proceed time, so we can say, okay, let's proceed time, let's say 5 seconds or something like that, and then raise hazard. Then we want to assert that the hazard state is active, right? So let's do that and say, okay, hazard lights. Hazard lights should be active. I will run this test, and it fails. So when I press on it, then it says, okay, it's asserted. So hazard lights was expected here, but it is in the regular right blinking state, right? So that is not what we expected. So what else? So when we also have a coverage. So this test case covered all elements of the signal control state machine to 33%. So I will just click on it, and we can see which elements were visited by the state machine, by this test case. Yeah. So we started the test case, and then after that, the idle state will be activated because that is an initial state. So but this is not completely covered because not all outgoing transitions were taken. So that's why it is yellow. All those things which are red were never executed at all, right? Those which are green were executed completely. So here we had this transition to the right state and went to the regular blinking state directly. Yeah? So that's why this transition is green and also that state, but we never visited the comfort state, and that's also why the right state is not completely covered, and so on and so on. So we have an overview of this coverage. This can also be exported to HTML to document the current status. Normally, it is feasible to have some kind of or implement tests for 100% coverage. Okay, so then next is to fix the state machine. So then let's go ahead and say that we want to go from it's a transition from here to the hazard lights. Oops. When the hazard state is the hazard event is raised, right? So we have an input from the hazard button. So when I press the button in the middle, then this state machine will receive the hazard event, and so it can switch to the hazard lights. Okay, so let's go back to the tests and say let's run it again. Then we see that the test is green, and we have even a higher coverage because also the transition back to the hazard lights was executed. So that also provides an impression on how to, so that test-driven development of the state machines is possible. So I can first write it. So now I detected an error, of course, but it could also be vice versa. I say, okay, that is a new requirement, and then I add all tests for that requirement, and then I will simply fix the implementation or extend the implementation. So I added a new feature here, and then it is executed. Okay, so then let's go to the last step, and we will generate code. So I will simply switch that off and go back to our other perspective. And now we have state machine modified, and now I want to generate it. We have a generation configuration here. So that is an additional configuration to configure the generation process. And I just say, okay, I want to generate C code. And we have a generator model that refers to some code generator, and we have different kinds of code generators. We have a C code generator, a unit test code generators, which generates unit test code for the unit test that we have seen. We also have a C++ 1198, so that is a compliance level. So for instance, C++ 11 code generator makes use of smart pointers or can make use of smart pointers, while C++ 98 that does not do that. We can export the images, Java, Python. That is what I've installed here. Code generators can be extended. So also users of us define custom code generators and register those with the IDE or with the modeling tool, so that we so that they can be installed like any plugin or an Eclipse tool, right? And that is basically what I also did here. So I installed the ITEMIS create plugins from our update site, and that is so can be integrated virtually in any IDE. Okay, so this is just for configuration. Then I can say, okay, let's generate code, but it can also be integrated in the normal build process. So when I build the project, then also the code is generated. And now the configuration that the code is generated just after compiling. So I do build twice. And now we have our turn signal control loop binary file created. And I will upload it to the device. So let's do that. Now it is done. Okay, so let's try if it also works on the device. So I will simply do the blinking, and when I press the middle button, the hazard button, then it goes to the hazard state. Yeah. Okay, so that is how that works. So then I can switch off and go back to the blinking state. So of course, this is just not complete, but I think it's fine for now. So the complete signal control looks like this. So there are different ways also to, when you come from blinking to hazard blinking, then and go back, then you go to the last state of the blink state. So we use histories here, for instance. So this is a little bit more elaborated and closer to real requirements. Okay, as a very last step, let's take a look at the buttons state machine. And I said that this one is a little bit more specific regarding the integration with the target language. So what we see here is that the state chart domain, we call it state chart domain, is not the default domain. So we have installed two further. So SXML, and the other is a C++ domain. So that is kind of a profile which tells the tool also to take a look at C or C++ code. So we selected the C domain, and you see that we import different header files. Yeah? So I have this main header file generated from the IDE here with all those defines. Oh, sorry, I'm wrong. Yeah, buttons, where's buttons? There's buttons. I also have the GPIO definitions and all those hardware abstraction layer stuff. So what I can do now here is, of course, for instance, call operations directly from C. So by importing it to the state machine, all those definitions or declarations become visible to the state machine, and we can access all operations which are available, like reading GPIOs and so on. Also accessing types like GPIO pin state and so on. This is a type def, and also accessing the enumeration values. So different to C, we have a fully qualified access to enumeration values like here, and so you can directly interact with C. You can even define a variable and say, okay, I want a variable X. And that should be some specific type, like a function that is a function state, or the so we also have these C integer types which are provided implicitly in the C domain, so we can then choose more concrete data types. So, and that is also validated. So if you write custom code or manual code and you rename a symbol, then it will also be validated, and the tool will tell you, I don't know the symbol, you may have changed things, and then you can fix that. So that is how that basically works. So I can define here the GP, or the kind of here, pin, for instance, a GPIO pin state. It could simply be defined as a variable. Okay, so just 6 minutes left. So, but I'm done with the topics mainly. So if you have questions, then first I hope that you enjoyed the presentation, and maybe you have a lot of questions. So if you have questions, then please ask. There is some time left. So if that is not the case, then thank you very much. I'm not sure how slides are provided to the audience, but I would do that, provide the slides if there is some channel. Okay, so thank you very much. And the next one can continue.
Thank you, Axel. Hello.
Yeah.
Yeah. Thank you, Axel. Thank you so much for your time. The floor is open for a few questions. If you would like to ask a few questions on ITEMIS, you could ask Axel. This is the moment. Actually, I have a personal question. Is there a list of hardwares the tool supports?
Yes. So we really so as you see here, we can generically integrate with STM, but also with all other IDs, so Texas Instruments and so on. So the tool is not directly coupled to the hardware. So you can generically use it with any other with any IDE and with any hardware. So the main thing is that you require C or C++ to implement that. And using this deep C integration, we can interface any thing. Of course, there are a lot of examples for specific hardware where we set up example projects and you can access them for free. Yeah? So, I will also provide this example that I presented here as a free example if you are interested. And there are some specific implementations for like how can I integrate the state machine timer with the hardware timer and so on. They're explained. And that is not code that is generated, that is set up manually, but there is just few code on that. So just to give a short impression on that part, I missed that. Sorry for that. Let's take a look at the main. Then we see that we simply import here all those state machines, and then have some definitions like I want buttons, I want to blink state machines, a flash state machine, and a signal control state machine, and I want to set up a timer service. And then, yeah, can also increase that size a little bit. And then everything is basically set up here. Yeah? So everything is set up, and that generically runs on this hardware. And it simply uses hardware abstraction here. So it's quite very comfortable. So to answer that, virtually any or every hardware is supported.
So that extends me to another question, Axel. How about AUTOSAR support? If we are able to build the application using modeling, will it be able to simulate a BSW stack for testing? Is there an option for that?
No, we cannot. That is not yet included. So as you may have seen, the main application state machines are independent of the base software layer, and so that is these are a little bit decoupled. So the positive effect is that you can easily test those, but yeah, so it takes extra action, and users of us do that to integrate base software layer. But of course, if you have means for doing that on your in your project, then you also extend the unit test code generators to integrate all that stuff. Yeah? So that that is possible, and there are projects where that is done. Yeah?
Sure, I get it. Okay.
Yeah. So maybe we will provide an integration with ECU unit in future. Yeah? So that is something that we currently do in a customer project, and maybe will also find its way into the product then. Yeah?
Yeah, got it. Yeah.
Other questions?
Any other questions, please? All right. If you have any questions, you could also write to Axel. We'll give you all these details as well. And thank you, Axel. Thank you so much for your time. It was definitely a very elaborate and a detailed presentation of the tool. We really enjoyed it thoroughly. Thank you so much. Really appreciate your time.
Thank you very much for listening, and I hope you enjoyed the session. Thank you.
Yeah.
Feel free to contact me.
Yes, so let's move on to the next session. The next session is something that is very interesting. Certain questions that always lingers why do I have to learn this? Why do I have to learn that? The tool chain keeps improvising. The tool chain keeps changing as we move from organization to organization, and we are in a constant learning mode. I have with me Mr. Arindam Lahiri, who's going to take you through the next session. He will actually guide us on what are the career opportunities that is available for automotive software engineering. So Mr. Arindam Lahiri has been working in this automotive industry for more than three decades, and he is not just working as an industrial engineer, but he is also has a wide range of experience both in the training and in the education field. He started his career with Maruti Udyog, okay, and he has also had an entrepreneurial stint as a director and co-founder of a company called Career Launcher India. He's also right now in the advisory board of many startups, educational institutions, and policy review committees of many state and central government ministries. So we are very fortunate to have Mr. Arindam Lahiri, who is going to run us through on some of his experience and some of this vision on what is the opportunity for the automotive industry, for automotive professionals. And he will also share some of the experiences and the policies of the government, which will help you ascertain where you will be placed or where you would like to position yourself in maybe the next 5 to 10 years. Thank you so much, Mr. Arindam Lahiri, for joining us, and over to you.
Thank you, Karthik. I hope I'm audible.
Yeah, you're audible. Yes, you could share your
screen. Share my screen as well. Yeah. Yeah.
Yes, your screen is visible. Please.
Right. Fantastic. Thank you for having me today as part of this very interesting and exciting range of sessions. Been fortunate to hear through a few from time to time during the day-to-day. And I'm very sure the participants would have gained a lot of interesting insights into various tools, techniques, opportunities across the globe. And that's fantastic, because today I think really the globe has shrunk, and we are able to exchange our thoughts, ideas so easily and so effectively across various time zones, various geographies. This itself is all due to softwares. Of course, hardwares are important, but software is also equally important. And anything you do in life actually fundamentally boils down to having the appropriate hardware with the right software, even in human relationships, actually. So I do see it that way. Given the range of technical inputs that has come, I'm going to be talking about something very, very different. But I'm sure this will raise a certain level of understanding and focus in terms of why you are doing what you are doing, and what is the kind of possibilities that exist in the larger automotive industry. Directionally, software has already been integrated in many areas. However, there could be many other use cases, many other example areas where one could look at, being able to apply the knowledge and the skills that you gather during your work life. But before I jump deep in a little bit more into the automotive software, let me also tell you about what is this framework of skilling. And you must be wondering what is this Automotive Skill Development Council, but I'll talk about it only towards the end. But the larger, requirement of skilling in industry and the larger skills required in the automotive industry today as we see it, because we work across the entire value chain, right from R&D engineering to manufacturing to sales and service to even drivers, and many of the softwares that you would be writing or designing would actually be used by this set of people. And when you know your user better, I'm pretty sure that is when your piece of software will also have a much better effectiveness and an efficiency that we might be looking at. So if I look at the whole Skill India mission, of which ASDC is also an integral part of this part of the activities, there are 3 strategic priorities that we have for skilling as envisaged by our key ministry, the Ministry of Skill Development and Entrepreneurship, which is the apex ministry in the country, to focus on how skilling ecosystem will need to be supported and taken forward. One is, of course, the integration of education and skilling. And this is where I think a very important, I would say, major reform. And many of you in this call probably weren't born when we in India had the major economic reform of 1991. But having done that economic reform, I think it was very important for us to follow up and do a major education reform. However, it has taken us all close to 30 years to be able to do that, unfortunately. But finally, it's here, and the document that I'm referring to is the National Education Policy 2020, or NEP 2020 that we are talking about, which is bound to make education and skilling very flexible. Having learned practices from across the globe, this policy is actually trying to enshrine every good practices or best practices across the world to be able to get this done, where seamless movement across formal education and vocational skills is possible, and people will be encouraged, students will be encouraged to do so. Skill India Mission also has a priority in terms of catalyzing demand for formal skills. Of course, those of you who are in the software industry would know this very well, because this is one of our flagship industry as far as global supply of manpower has happened, and because of the formalization of the skills. Right from the very basic A-level, O-level to BCAs and MCAs, or the programs that this country had produced about 30 years back, to the NIITs of the world, which has done software courses. People have actually utilized those inputs and been able to leap forward in their career even globally. And that's what we are looking to emulate across all spheres and all sectors of industry application to, basically the Honorable Prime Minister's vision is to make India the skill capital of the world. And therefore, the priorities that we have been set forward on skilling is very, very important. And finally, enabling an ecosystem to be developed. So the whole Skill India mission has today created chain of organizations, startups, digital technology startups, etc., around skilling and skilling of manpower across various sectors, various domains, at various levels of skilling as well, right from beginners to advanced expert level of skilling. So this is the background for skills. The importance of skills, I think, is quite well known. Access to skills allows individual to gain economically as well as have social mobility. It's one of your passport to move up the value chain at an individual level and at a societal level. For the enterprise, it improves productivity, it lowers operational costs, and it, of course, adds to the quality of the output, and which effectively manifests itself in terms of the costs, because there's a cost of poor quality that we all know about. And finally, overall, at a macro level, it impacts the economic growth of the country, the growth of GDP per capita improves, and that's where skilling makes a significant difference to the entire country, starting right from an individual to the society that he is part of, to the country that we are all part of. And that is so very important for us to pick up the skills, right skills, for any area that we choose to work on. If I look at what are broadly some of the key skills before I come into specifically on the software area, there are 8 major skill areas of future that has been identified. Some of the reports place it top 5, top 3, top 10, etc. I picked up something which is a list of 8 major skills, but by and large, these skills would keep reappearing in various reports. And not a rocket science, but I thought this would be a great opportunity for me to kind of pause and talk about it here at this, Tech Day when I'm talking about skills. We are looking at skills around engineering and design, the first 2, which I must talk about, that India has largely become like a service economy straight from agriculture, and we kind of missed the boat on manufacturing. But there has been a very sustained effort, at least over the last 8-10 years, in terms of, or maybe 5-6 years, in terms of a mission called Make in India. And I think today a lot of that is turning back and saying, can we design in India? Can we create products in India? Today I was in another session of the ministry in the morning, and we were talking about how India has been able to, deliver 5G technology with local support, and local operating systems. And the discussion was around, the point that can India take the lead to launch the 6G to the world? I think we are at a stage of development in this country where we do not need to do a catch-up, but we can actually lead the world in terms of leading them to newer technologies. In the automotive industry, when I started way back in 1992, more than 30 years back, we always used to look up what US is doing, what Europe is doing, what Japan is doing, what Korea is doing. And we would just want to say that how can we minimize the gap? But today in certain areas of automotive applications, I think we are way ahead of the West as well. And I'm pretty sure you understand that. So software definitely is a very natural strength of India today. But across many areas of application within the automotive sector, we are truly ahead. I mean, if you look at just emissions standards, for instance, we've jumped from BS4 to BS6, skipped one level, which no country has done in the past, and that too within a period of 3 years, from the time the BS3 to BS4 transition happened. So I think Indian technology power is no low, and there is significant opportunities there. And I think engineering and design is an area that we must remain focused on for the next few decades for India to lead the world, and the rest of the world needs to follow that. So it's something that I think all of you younger professionals will be a witness to that. It's my firm belief, and you will be a major contributor to that as well. Next is 2 blocks I'll again take together, which is analytical skills and problem solving, which is very natural, and especially even if I talk about in the context of software engineering. This is some of the core skills that you do bring into the table in terms of analyzing a problem and solving that particular problem. Work ethics, that's very important. Software industry of late has had certain questions around ethics, around moonlighting, etc., etc. A lot of debates around it. Ethics always plays very important role, but work ethics of a professional is very critical. And I think if the Western world had developed a lot over the past many decades, one of the core principles on which that development happened or that growth happened was largely around their unflinching commitment to work ethics. And that is what we need to emulate or actually do better in India for the future. Project management, everything that we do today is going to be around project management. I do work a lot closer to the government, and I do see that the government has very, very strong focus on project management today, which was unthinkable maybe even 5, 7, 10 years back. Everything is monitored on milestone basis, on resources usage basis, timelines, everything. And software engineering is always largely a project. And I think this is again very relevant from a software engineering perspective. And then finally, marketing and customer service. A lot of people probably think that that's something which is left to a marketing professional. But as an engineer, as a software developer, as a software engineer, or any specialist engineer or any specialist technical resource, please understand whatever you are going to be working on is going to be used by a customer. And the customer are finally going to be the final judge of the work that you are doing. Your internal bosses might be judging you or evaluating your performance. But if the customer is not happy, that doesn't hold you much in good state. Or alternatively, if your customer is extremely delighted or happy, I think boss's evaluation is not of that high a consequence. So making sure marketing, I think, is also sometimes very hyped up. People think that, oh, there are marketing budgets, this, that, another. But marketing, traditionally, if you look at the very, very traditional model, I know that model has evolved to a 7P model today, but I look at the 4P model that we all got exposed to when we were in preschool. What does it talk about? You need to have a great product, you need to have a great price, being able to have a cost so that it supports a great price. It needs to be there needs to be a place where it needs to be deployed. So you need to know where is it going to be deployed, and a promotion, which means that people must know that that is what is available and it's not boxed up somewhere as somebody century later will figure out that what have you done is eureka. So it's important for us to share and explain it to customers. I'll not go too much into it, but it's primarily what we talk about in terms of professional skills, critical thinking, our ability to focus on tools, um, techniques, and that requires various skills and proficiency, and that you must be able to deliver that skill and proficiency by focusing on what is required of you. The professional attitude and demeanor, that at least is very, very bare minimum. How you react to feedback, how you understand the needs of your customer, how do you maintain your emotional stability, mental health. All of this is, a lot of time we get too sucked up into the technicalities of the work that we do. But please remember that we're talking about a man and not a machine. We work with machine, but we are not a machine, So we have our softer side, and we must be very clear that this is something which matters a lot. You might be a great software engineer, but if you are unable to work with teams, what the potential that you have to deliver is not likely to get realized, and therefore you may not get the recognition or reward that you actually should naturally expect. Be forward thinking, ability to look at the future. So sometimes we get so engrossed into doing what we are doing, we forget that the world is not going to be the same 2 years down the line. And if we are going to expect that it is going to be the same, then we are making a fool of ourselves. You must, and if I contextualize in the context of a software engineer, I would say that your ability to learn newer tools, newer techniques, what is it that works, what is it that doesn't work, why doesn't it work? There has to be a constant curiosity and a questioning that you must be part of in your journey as a professional, as a software professional, to look at what is being done around you, and the wider the net or wider that you can see around you, the better it is for you, because you will have a much more diverse view, and the diversity is going to enable you to be better prepared for the future. We all talk about a VUCA world going forward, volatile, uncertain, complex, ambiguous world that we are living in. We don't know what's going to happen for future. Nobody expected in January 2020 that we will have 2 years of lockdown almost in India, partial or full lockdowns. Pandemic, many generations during this period post World War II had not seen impact of such a large scale across all countries in the world. It was not a localized event. And a lot of learning happened, a lot of understanding happened, and people, I think, have a lot more preparedness for the future in today's context. But then we still don't know whether it stops here or are we in for something more. And how do we prepare ourselves individually as a part of the organization itself, the customers that I serve, how can we prepare ourselves for that? And that is something which is a very important professional skill that must be there along with all of your technical skills. The way we have looked at automobile at ASDC, when we interact with a lot of customers, a lot of customers of ours are largely people who work in the industry, whether they work for an OEM or a component supplier or a dealer or fleet management company or a fleet owner, etc. Or training institutions, assessment institutions in automotive space, content creation institutions, etc., universities, colleges, ITIs, etc. So we're talking about a 3S model for the skills in automobile for the emerging automobile market in India. A big part of that is around smart automobile or smart mobility. And we all know that there is a significant development that is happening around the way we design automotives, the way we design design and manufacture automobiles and its parts, the way the mobility happens, the alternate energy, electric vehicles, other alternate energy vehicles, biogases, hydrogen, definitely another very upcoming area, flex fuel engine systems. A lot of these applications today opens up new opportunities for software application, because software is a great enabler for these technologies to work on the ground on real time. And that, coupled with the advances in telecommunication or communication networks in terms of 5G and above, as we're just about starting to use 5G, and we're already talking about a 6G. But I mean, I'm just saying that that's how the communication networks are, advancing, and that is also allowing a lot of things to be done on a real-time basis. So this is around smartness, and of course, the smartness is around, not only making our work easy, but also about the average car user's experience of mobility or experience around moving from point A to point B, being much more exciting and much more enjoyable for them to go ahead. The other two S's are also very important, though seems like it's on one corner of the slide, but sustainability in today's context is becoming very important. So whether we can use software as a platform to make things more sustainable when we are developing our mobility solutions is very important. So one application definitely that comes to my mind is a shared mobility or an aggregator-based model, which has been possible because of software applications that is been there. And I think that's a great contribution of a software application into making this world much more sustainable. But there could be many other opportunities. And sustainability today as a global theme and as an important theme as part of the automobile industry is very critical. People are working on sustainable materials, sustainable processes, sustainable life cycle management of parts, reusability, recyclability. Everything is so very important into this context, and that is where the enablement of various technologies to applications around automobile, it makes it so very exciting. And last but not the least is around safety. And again, software plays a very important role in enabling some of the safety features of vehicles, whether it's from emergency braking, lane guidance, etc. Sensors and getting inputs or stimuli from sensors and converting them through a software application into actions is something which is becoming more and more commonplace. Gesture controls, how can that help? Maybe steering, maybe indicator control. I don't know. I mean, why do I need to necessarily pull a switch to do my wipers or to do my indicator lights. It could be just a hand gesture that that a system can read in and allow me to do otherwise, So that could be there. That could be voice control. Voice control, I think a lot of voice control elements have already come in through our infotainment, but it's largely focused on infotainment, not necessarily very mission control as far as the vehicle movement is concerned, but maybe there are some applications that people are already working on. Many such applications. And how do you make it much more safe for people to drive a car and reduce the loss of life, maybe potential accidents, reduction of potential accidents, etc. So this 3 years model for skills is, I think, very, very exciting for us in the automobile industry. And at ASDC, we are looking at some of these as the whetstone for the kind of training programs, skill programs that we are looking ahead for future. This is a very interesting piece of data that I had stumbled upon a few years back, so it's somewhat dated. I don't know if there's a newer version of this. It says, from a case perspective, by 2030, 77% of vehicles is supposed to be connected devices. Could be to phones, cloud, via telematics, whatever. But they will all be connected vehicles. They themselves, the vehicles themselves become connected devices. 15% of new cars by 2030 will be autonomous, but again, autonomous has various levels. So I don't know what level of autonomous are they. Fully autonomous, I'm not too sure, but maybe I don't know. I might be wrong. Shared, 9% of global miles traveled will be via shared mobile systems by 2030. Maybe it has already happened. This is data that was done maybe 10 years before 2030, maybe 2019 or 20 data, this I'm talking about. And nearly 145 million electric vehicles will be on the roads by 2030, probably even more. Given the kind of adoption of electric vehicles, especially in certain segments, two-wheelers, three-wheelers, and buses. In India, China has already had significant penetration of electric vehicles. But there's just puts in context the opportunity, for software application, and each one of these are going to happen because of effective, efficient software applications. And therefore, if you want to build a career in automotive industry for software, this framework, the case framework alone, is going to create millions of jobs across the world in terms of development, in terms of deployment, in terms of further analytics around it. And I don't know, it could open up a lot more opportunity for future as well. I'm pretty sure that is how it will happen. These are some of the application areas of automotive software that we've been trying to take a look at it and therefore create courses around this. Autonomous driving and ADAS, the advanced driver assistance system, definitely is one area. Electric and conventional powertrain, because there is a lot more control units, embedded systems, software that are being used progressively more and more in all kinds of vehicles, even with two-wheelers and three-wheelers today. Connected vehicle, obviously, connected vehicle will need softwares compliant with various communication protocols. And therefore, the whole V2X model is effectively a huge area of application of automotive software that is going to be there. Post sales, post the vehicle being on the road, there are huge applications around vehicle diagnostics and over-the-air updates of softwares, and that itself is a big market about how do you push that into different vehicles, you know, what kind of architectures you need to have, etc., etc. I think there are various applications, you know, the softwares, the middlewares, the farmers. Anyway, the whole system needs to work and integrate very seamlessly in order for these to happen as a seamless experience for the user at the customer end. AUTOSAR, the open source platform that is gaining a lot more ground today, I believe. We are seeing significant shift of automotive component companies moving from proprietary software systems to open source systems, you know, building on top of it. So that's definitely there. Vehicle engineering and design requires significant amount of today software, and not only design, I would say even testing. Testing of vehicles will need a significant amount of software applications that one will need to be looking at, and you know, how do you conduct a test itself would be a significant market for software development. And finally, of course, the vehicle is to be produced in a factory, and the factory today is talked about as a digital connected factory. More and more, you know, isolated, automated factory systems are being integrated pan factory and then across multiple units of the same organization. And tomorrow, further maybe aligned very closely with your OEMs, and there are already examples of that happening in many areas. OEMs typically have had a structure of having component supplier clusters geographically close by, but they are also becoming digitally close by over the years now. And that itself is making a very significant opportunity available for automotive software applications. This is another thing that I've had picked up about automotive software industry share by 2025, where it talks about significant amount of software around vehicle management and infotainment largely, and some bit of it around autonomous driving, safety and security. When we talk about connected vehicles, especially, these are some of the key chunk areas where probably a lot more work is getting done. But I'm pretty sure, you know, these charts will keep morphing as we go, because when we started looking at automotive software applications, a large bit of this pie used to happen around infotainment, which is probably one of the early areas. And today it's shrinking in the overall pie. The overall market is not shrinking, it's still growing. But as a percentage of the overall application of software, it's kind of shrinking, because obviously there are more and more areas that are getting picked up, you know. So some of those will make very interesting use cases for future. Let me just take the last 5 minutes for me to share a little bit around ASDC. What is ASDC? It's one of the first sector skill council. Today there are 36 sector skill council in different sectors. It's part of the National Skill Development Corporation and under the regulatory body in India called National Council of Vocational Education and Training. We are promoted by the 3 national bodies in the automotive industry, which is ACMA, SIAM, and FADA. And we are supported by 3 ministries, which is Ministry of Heavy Industry, Ministry of Skill Development and Entrepreneurship, and Ministry of Road Transport and Highways. Our vision and mission is to upgrade automotive skills for higher value additions by making making the output for the enterprise, as I said, more productive, which leads to more economic activity and subsequently creates more jobs. Making skills aspirational, integrating it with academic pathways, the piece that I was talking about in terms of the National Education Policy 2020 NEP, honoring and celebrating skills. So we have skill competitions now globally, and it's been there for many years, but India has been part of it over the last 12, 13 years now, where youngsters across the world compete on 56 different skill areas globally, and they compete in a skill Olympics format where they represent their country and compete with other countries. The latest edition happened in 2022 globally on the World Skills, and India was in the top 10 in terms of the medals tally across the various areas. Automotive software application could definitely become one of the areas. Right now, I think in IT, there is connected factories as a skill. So that has a lot of software application. Then there is mobile robotics. Then there is mechatronics. Many of them have elements of software skills that are also tested as part of this world skills. What we do qualifications, and content qualifications are basically curriculum and design of a course, and then content for that, both learning content for the learners as well as software AR, VR content as well. Training of trainers and assessors who would impart these training or assess these trainings. Affiliation of various training partners and training centers. Assessments and certification are certificates are government recognized certificates, which are also creditized today in alignment with the National Credit Framework Policy. We also do placements, including apprenticeship placements. Apprenticeship is a huge opportunity in this country in terms of giving new people coming into the workforce an opportunity to work as an apprentice in any area. It doesn't necessarily need to be a shop floor area. It can be any particular area. As I said, we support 4 skills in World Skills and India Skills. We've won a bronze medal in 2022 and 2 other medallions of excellence in 2022. And we work as implementation body to implement projects in CSR, various government, non-government projects, and some special projects for multilateral agencies like UNDP or World Bank, etc. What are some of the areas where we do offer courses? We currently have courses designed for AUTOSAR application areas, for ADAS, for on the service side for onboard diagnostics. Then we have modules around automotive cybersecurity applications, and also for smart manufacturing around connected factories. We work with various training providers, including skill universities and other universities who are willing to offer programs like this, either as a specialization of their core engineering programs, or offer specialized courses, short-term courses within the campus, within the facilities of the campus, for their own students as well as students outside of the campus as well. So I will stop here, and I'll be very happy to take any questions that anybody may have around the career opportunities or anything to do with skills.
Anyone has any questions? Thank you, sir.
Thank you. I hope
was
it was
indeed,
useful.
yes, sir. Like it was very, we gained insights on the application areas of the automotive software and global career opportunities. If we are well versed in automotive skill sets, we could see a good scope in automotive industry in future. Thank you for the gainful insights, sir.
Thank you. My pleasure.
Thank you for your time.
Thank you.
Okay. Everyone, before we go on to the next session, I would like to introduce Mr. Sundeep, an UDS expert and consultant for ANCIT. Sundeep and his team has built an UDS simulator for the benefit of automotive community. I would now like to call upon Mr. Sundeep to show a small demo on his product.
Thank you, Sri Shakti.
Just
before I start, I think this will not be a demonstration session. It will just be an introduction to what is the product we have made. And the actual demonstration will happen in the monthly webinar, which ANCIT does every month. So that is coming Thursday, we'll have the webinar. Okay. So just give me a moment. I'll share my screen.
Sure.
Is my screen visible?
Yes.
Presentation mode. Okay. Yeah. Hello, everyone. So I would like to introduce about the UDS simulator project, which we are handling at ANCIT right now. So as you all know, diagnostics is pretty much part and parcel of the automotive embedded projects which we have. And as part of that, nowadays we have lots of electric vehicle companies, startups which are coming into the automotive area and building their own, designing their own vehicles, bikes, cars, and all. And they would like to have diagnostics as part of their embedded solutions. So this was the place where it was a trigger point for us to see how we could contribute to the automotive domain in terms of bringing diagnostics as a package. Of course, this is also already available in the market in AUTOSAR classic legacy projects. So what is different with respect to the UDS simulator, which we are doing at ANCIT, is we try to address two different problems. One is for the EV companies or any new companies who would like to have the UDS stack as part of their ECU. And the second one is there are lots of tooling companies who build testers and diagnostic testers for the automotive world who do not have any kind of black box which they can use to test this particular UDS diagnostic tester which they create. So as I speak about that, what does the simulator offer? So the first one is we provide a UDS diagnostic stack, which is compliant to all the ISO specifications, this software can be ported to any of the customer specific ECU. And this stack specifically consists of the layers, that is the application layer, the presentation layer, the services layer, and the transport and network layer services. So these are the areas which this particular stack would cover as part of the diagnostic protocol stack. Apart from that, as I was also telling you, this particular diagnostic stack also can be together with a custom design board from ANCIT. We can consider this as a black box, and any diagnostic tester which is connected to this can send all the UDS compliant services, and this particular black box will act as a ECU and to test that particular diagnostic tester. All the different layers will be configurable. So in the next webinar from ANCIT, which will be on the coming Thursday, we will have a detailed discussion on what is this UDS simulator, what are the different possibilities we have, how do we use it as a UDS stack for your ECU, or how do we use it as a black box will be shown as part of that webinar. Saying this, I would like to conclude this particular short session to say we look forward to meet you at this particular webinar. The link to this webinar will be published shortly, probably a day by Monday by ANCIT, and everyone who are interested, we welcome you to join the webinar. Thank you. That's what I would like to present.
Okay. Thank you, Mr. Sundeep, for your presentation. I'm sure this UDS simulator would be beneficial to the lot of startups and OEMs who would need a portable device. So the participants kindly stay tuned for the upcoming webinar to know in detail about this. Thank you once again.
Yeah, thank you, ANCIT, for giving me this opportunity. Have a nice day.
Thank you. So now I would like to move on to the next session. The topic is connected mobility, and we have two honorable speakers with us. The first person is Mr. Alok Das, founder of
Sri Shakti, sorry to interrupt. We can wait for a few minutes. They are yet to join. Yeah.
Okay.
Yeah, 2 minutes, please. We will wait and then we will start. Yeah.
Okay, you can give me some
yeah, sure.
notification in the chat. We will start.
Will do. Yeah, thank you.
Okay, thanks.
Good evening.
Good evening, sir.
Yeah, Sri Shakti, we are good to go. Yeah.
Okay, thanks. Hi. Hi, everyone. Now, our next session would be on connected mobility. To handle the session, we have two honorable speakers with us, Mr. Alok Das and Pramod Krishnaya. So I'll go with the first person, Mr. Alok Das. Let me share my screen. Hope my screen is visible. So Mr. Alok Das is the founder of Korgas, a startup which is working on disruptive electric vehicle platform. It is also funded by Government of Karnataka and is among the top mobility teams of NASCOM. Mr. Alok Das has 16 years of diverse experience in product design and development, intellectual property and innovation management, program management, and also in starting a new business. He has completed his bachelor's and master's in mechanical engineering from BITS Pilani and specialization in intellectual property law from National Law School. He has also worked in aerospace industry, industrial products for oil refineries and electric vehicles. Being an innovator, he has more than 100 active patents in 40 countries. He is also a visiting faculty at ARAI and takes technical sessions for SA India and various engineering colleges. We are glad to have you, sir. The next speaker, Mr. Pramod Krishnaya. He has 20 years of experience in automotive domain experience, and also he has a significant experience in system integration of both mechanical and electromechanical products, testing, validation, and program management. He has been working in various applications, defining the roadmap, budgeting, technology evaluation, and outsourcing-based delivery. He has handled 6+ programs in mechanical and electromechanical product development and system integration. He also has developed electromechanical fuel system along with controller for emissions of engines. He also has developed EGR valve with BLDC motor and control systems. Currently, he is the business head at Device Electronics. So we are glad to have you, sir. On behalf of ANCIT, I extend a warm welcome to both the speakers to handle the next session, Connected Mobility. Thank you, sir. Over to you both.
Thank you very much.
Thank you very much. So we are going to start sharing our screen. Thank you, ASDC team, for the opportunity to talk to the wonderful audience. And today we are going to talk about the connected vehicles. I'm just going to share my screen. I hope you are able to see the screen.
Not yet, Alok.
Is it coming up?
Yeah, it's visible now.
Sure. So let's get started. Pramod, over to you.
Oh, thanks, Alok. And good evening, everyone. And thank you, ANCIT, for this opportunity and this tech talk which we are having today. Alok, we keep this kind of interactive, and then also we let the participants be interactive with us. And as we all know that about connected vehicles, we are seeing this also when I watch with my son. Is talking about Little McQueen, and there what do we see? We see these cartoon cars talking to cartoon trucks, and one of it peer vehicles. And so we engineers definitely have worked strongly to get it into the reality. And while we saw it on TVs with children, and in reality, connected vehicles is here in front of us. This is nothing futuristic. This is at the moment trending. And there are a lot of industries, hardware and software people working together. And let's proceed, Alok.
Yeah, another interesting thing is that, this can definitely remind me of, the Iron Man suits that they create. They're like, Iron Man is able to control multiple set of suits in the Iron Man movies, and it's completely automated, and he can give the command and functions and things like that. Well, in reality, it's not going to be possible to create such kind of a thing in near future, but definitely I think the connected vehicles are definitely there. And as the technology evolves, we will see more and more sophistication, futuristic stuff getting embedded into the connected vehicles. Let's get started.
Yeah. So in reality, the enabler is the development of cooperative intelligent transport system, right? And connected individual vehicles will be the technology factor. Most of us, we are all aware that there is a lot of evolution in the mobility sector, and technology is definitely catalyzing that growth and progress. And most of the OEMs call with their own acronyms, right? We know these acronyms as CASE, ACES, cases, connected, autonomous, safe, electrified, and shared, right? So all these are well known, and everything speaks about connected mobility. Autonomous drive systems becomes a part of the ecosystem. While we are connected, we are also being very safe. And then electrification is one of the key things which is at the moment progressing a lot, and it's dramatically changing the automotive industry. And there is also the social sector who is talking about shared mobility. And not only from the social perspective, right from the e-commerce guys to individuals, shared mobility is going to be pitched. Next slide, please. So let's see about some kind of small statistics here. 25% of the car buyers are talking about or prioritizing their value for connectivity soft features, and also negotiating with engine power or fuel efficiency. They are willing to pay more for connectivity than the engine performance of fuel efficiency. And we have Juniper, who is estimating about 200 million numbers of connected vehicles worldwide by 2025. I think this number is a little bit more from the present statistics, because everyone feels this is more viable. Also, there are certain things, and there is acceptance also from the consumers. Why?
I think, sorry, go ahead.
Yeah, so while people are taking 2 steps towards technology, they're also taking 1 step backward. About 72% of people still feel, consumers feel, that there could be certain glitches that could come through these connected cars, or might be ending up in a kind of crash, which I think is still in the testing phases. They are definitely right, but that's how the markets are moving. So Alok, how do you see this one coming up?
I think it's already kind of over here that we are seeing more and more vehicle models getting introduced with the connected mobility. And I think what's overall, when we look at the larger scheme of things, even not just talking from the perspective of the IC or from the electric vehicles, but over the IC engine vehicles are also getting connected. And like we are seeing more and more number of cars. And it's also the reason that the companies are, it's both ways. One thing is that, of course, the software is taking over a whole lot of, the hardware side of it, the control and side of it. So it's a benefit for the consumer that they are seeing a greater control over their asset, so which can be utilized in a different way. That's one part of it. And the second part is that when we look at for the companies, they are exploring new ways and means of providing services to the customer, and predominantly that's also happening is because the life of a car, I mean, like the reliability has improved leaps and bounds. So how do you kind of the loss of revenue because of the cars being more reliable in a way? What companies are coming up is different ways and means by which they can continue to have additional revenue generation from by providing some of these services which can be utilized by the customers.
Right. I agree. I echo that.
Yeah.
So here we see, when you look at the left-hand part of the slide in the top left corner, you see a lot of green boxes. In principle, this is actually mimicking our natural visibility. And who is doing this? We have a lot of sensors who are definitely coming into the business, and a lot of reliable sensors. And transportation is, and the cities and outside the cities with infrastructure, this is definitely catching up in the connected mobility space. And while we are talking about mobility, there is also in-car entertainment and voice control assist or personal assistant, whom we all know with Alexa, Siri, lot more, right? Google Assist. So they're also talking about why don't we connect to the home appliances, right? And just Alexa, and then from your vehicle, there's a lot of home appliances with your experimental labs running through your kitchens. It's actually giving inputs to how mobility can actually make an efficient life and comfortable life. In between efficiency and comfort, safety is definitely a factor which every engineer is also looking at in parallel. In this process of connectivity, you can imagine how much amount of data is being transferred over the air. And then Intel estimates about 40 terabytes of data for about 8 hours of driving, and with millions of vehicles, right? So cloud becomes definitely the software real estate. And when we are transferring this data, all connectivity is comfort, everyone enjoys it, everyone wants to be efficient. Automakers want to make a net zero using this feature. But there is also a threat. Cyber security is definitely a concern in connected mobility. And another functional vertical is definitely being in traction. There are industries putting a lot of money and investments to ensure that they have a secured product too. With connected mobility as a product, security is also being verified, tested before any launch. So, Alok, what is your thoughts on these?
I think definitely one of the key points which will come up during a lot of these discussions, and I'm sure that the overall large level ecosystem is getting ready for this kind of threats, where the a lot of these systems with a lot of data exchanges that are happening, it would bring a lot of possibility of the cyber attacks that can be there. So cyber security becomes all the more important. Like in we see example is that our phones getting hacked or the bank accounts getting hacked just by the message and all. Just think about it that just by sending some messages, or if somebody else remotely is able to take over your car, in-car entertainment, or maybe they are able to take some of the critical subsystems which are safety critical things. So there can be a lot of catastrophe which can possibly happen. So I think cybersecurity becomes all the more important while we move towards more of the connected mobility.
Yeah. So.
Yeah. So while we talk about the connected mobility side of it, let's talk about the vehicle use cases. So even though there are like 8 of them which are highlighted, we'll take a moment to talk about only 3 of the critical areas, because the predictive maintenance is obvious that we have, since the vehicle is connected, so the vehicle performance parameters can be maintained and the prognostics and diagnostics can be done, and even well before in advance, the commands can be sent remotely via the company servers to push the consumer or the user to go take the vehicle for service if there is an unforeseen, if there is a predicted kind of a failure. Similar thing when talk about the vehicle safety, security, upgradable vehicle usage, feature analytics. These things we will eventually cover in the presentation. But let's talk about the 3 element of it. So a lot of times, example is that during the COVID pandemic, Pramod, the car was not getting used, right? So overall wear and tear of the car was very limited. Everybody's, it's not just us, me and you, but everybody had seen that the usage of the car had gone down dramatically. We were driving less and the car was parked. So, but however, when we went to renew our insurance, the insurance companies did not bother about whether the vehicle is being used or not. So, it's something which can be tied up if we have a connected car. So the insurance
can be actually retuned or for the amount of usage that the car is going through. At the same time, if there is a user driver pattern where it shows that the vehicle is being driven at high speeds, so the probability of the crashes increase. If the, all these information that can be exchanged with the insurance company, under certain circumstances, these can actually be maneuvered with reference to the amount of wear and tear that is happening in the car or the user's pattern and things like that. So somebody who is a very good driver should be rewarded having a lower upfront insurance cost to be paid versus somebody who is an aggressive driver. So there can be a dynamic pricing which can be triggered out of the usage scenario.
Yeah, I think this one you also did mention, right? There was some discussions with Ather where certain reports. You want to talk us through that?
Yeah, so actually, if you see, the Ather typically generates a report using the app. Let's example is that a month or 2 months of riding, if you are riding. So Ather app generates a report based on the behavior because Ather is connected. So the app is monitoring your vehicle all the time and it can generate a report based on user. So one of the case which I was just having a look at is that, one of the user is a below average, above average rider. When it means above average, it means that he's a very seated rider and he rides the vehicle very slowly. Now, for somebody who is using the vehicle every day in a relatively manner, the insurance and all those things can be also dynamically priced with reference to that, not having a common yardstick of the depreciation cost of the vehicle every year and things like that. Of course, there can be different transfer functions or equations can be developed to come to the right pricing. But the short answer to that is yes, based on the user behavior, it can be done.
Oh, that's interesting. Means for us with connected mobility, even the driver, at the end, the consumer also gets some kind, based on predictive analysis, he pays less or more based on his driving pattern, right? So
yeah, in fact, what was your car? I mean, like, did you realize it, like, the car, you had to pay the same insurance cost during the COVID pandemic as well?
I agree. Right. So connected, in such cases, connected mobility will give those benefits to the user, and dynamic pricings based on, and I would more than say dynamic, predictive analysis is something that connected mobility will use. Based on the data collected, there is a prediction that happens, and then there is a prescription that happens. I think we touch upon in the subsequent slides.
Yes. So what does it mean? I mean, like, while we are talking about individual level, but imagine that somebody who owns a larger fleet. So even let's say if we marry these 2 points together, usage-based insurance and telematics and fleet management. So fleet owners typically would own, let's say, 3,000 vehicles. So Lithium owns 3,000 electric vehicles. So if Lithium Urban Technologies has to kind of have a dynamic pricing for the insurance, and the insurance cost is also something based on the driver behavior, which can very well be predicted in case of a connected car. So if there is an aggressive driver, the driver may not get a good incentive, because fleet operator has a first-hand data about the driving pattern of XYZ driver who is driving the car. So somebody who is a good driver, who's extracting more range or maybe better fuel efficiency, can be rewarded with a higher performance rating. So it becomes more easier and transparent for having a performance based on the driving style and things like that.
Agree.
What do you think about it?
Yeah, means these are the benefits which are foreseen, and applications and a lot of efficient applications are going to come through connected mobility, and this benefit will be passed on to the consumers. And then there is also the way we utilize this is also contributing how nicely we drive, and finally how safely we drive also.
So yeah, from the point of view of safety, what really is, the point is when you have a connected cars, it's imagine that your traffic lights and your different lighting poles, or it's basically connected to the central servers, and the car is also visible. So in case of a stolen car, if a car is reported stolen, the exact location of this the car can also be reported not just by the car GPS, but also by the respective, the traffic light system or the light poles which are connected to the car, or there's some exchange of data that is happening. So that can help the message across. There can be some specific cases where some criminal activities and things like that can also be predicted based on the location of the car. At the same time, you can trigger certain alarms in specific area for the getting some information from the car which has been stolen and things like that. So there are different ways and means. As technology matures, we also start having the more use case scenarios which will allow us to develop this further.
Yeah.
So one of the larger thing, let's talk about an example. So while we spoke about some of these topics on the previous slide, Pramod, now one of the best examples for the connected car tech is a Tesla supercharger network. Now this is the most recent updated screenshot from the Tesla supercharger network, which I have taken from the website. You can see the location of the supercharger. Now, what does it mean? So now, since Tesla is a connected car by default, it relies heavily on the 5G or the 4G data networks. So the Tesla servers are always aware about the location of the car. They are also aware about the state of charge, the state of health of the battery pack, which direction you are going. So let's say if you have to plan a trip in a Tesla from zone 1 to zone 2, let's say, or two, three different locations. So the servers are by default aware about your route, and they would predict the requirement for you charging your car at XYZ location. So they will include a supercharger on the way if you're going from one location to another location, and then it can predict the range based on your driving pattern and subsequent requirement for a supercharger for you to recharge your car and things like that. All this is happening is because of the connected car tech, because it's so well advanced that it's very seamless. It's very reliable system overall that has been developed over a period of time because of the algorithms which are running in the background, because of the visibility of the car information to the Tesla servers. So the exchange of data is great, and that's basically enables a connected car, which makes Tesla way ahead in terms of a car company, way ahead of anybody else. Leave aside the electric part of it. It's purely from the point of view of the data, which is getting leveraged for the machine learning and predictive intelligence and things like that, that can be leveraged because of this data, visibility of the data.
Right. And even I am very optimistic of how even the progress in India is happening. And even the government is actually giving out targets to have every 25 kilometers there is a charging station. And how does the driver know which station is upcoming? So connected mobility is going to definitely accelerate that vision. And there are many organizations who are definitely working along with OEMs. And such kind of pictures soon, I think we should see it on the Indian map as well.
Absolutely. I mean, like another point to add, Pramod, is when we have these, imagine this something similar on the Indian map. So when you're driving down, whether it's an IC engine car or a, say, the Tesla or electric car, so you can actually book a slot for refueling your car, or you can find out the fuel station on the way, which gives you of your preferred choice, or maybe you can find a charger network and the car itself can book the slot for the charging the car in advance by the time it reaches. And at the same time, the car will be also able to do transaction via FASTag or other mediums. So even the commercial transactions can actually take place using the connected car tech.
I agree. Yeah. Right. So in short, what are we talking about here, right, Alok? So we know software as a service. Many things came up as a service. So soon, or not soon, there are many things we are using service through mobility. So we all know this as mobility as a service. And if you look at the infographics, what we have, everything, right, from our cycles to the car sharings to the fleet rides. And then you have our healthcare system, from the institutions, from the government sectors, public transportation. We are talking about last mile mobility, right? So it is just not about cars, but we are talking about how a regular public who is in a metro station, when he gets down, what would he move? What would he use to get back to his ultimate location of home? So there comes this last mile mobility. and there is a service. There are many organizations, many startups, unicorns who have come up to use electrified vehicles. And of course, who is getting them there is the connected mobility. So a single person can know that what's coming up front and which mobility he can use to get to his home. So he might not necessarily to bring his own vehicle. So at the end, you see, connected mobility is definitely helping to achieve our environmental targets. So we have a great purpose, and the nation is getting there. Industries are working along with government vision and mission. So connectivity and connected mobility is going to definitely help to reach the targets very soon. And this includes various means, right from locomotions to airplanes. So everybody will be connected, and mobility is a service now.
And I think it makes sense because of the asset utilization would dramatically improve. Rather than like example is that in some of the cases, like, you know, where the people may not be using their car often, so they can actually leverage the mobility as a service providers to, you know, take the car for the time or the vehicle for the time they require, and that they can be done with it. And I think you can talk about some of the examples.
Right, and look at these. One place, at least what I would love to use is on the smart parking, because at the end we take our family out over the weekends. Cities like Bangalore, Pune, Delhi are so much crowded. We go in circles to find a parking lot. If I know that I'm not going to get a parking lot within 10-20 minutes, even if I want to circle my car, I wouldn't remove the car itself. So with that prediction, I am given a choice to take a decision whether I want to use my own car or just use an aggregator car, right? So this is the power of connected mobility. So we use, and then if you go to the next slide now, you have a lot of startups in the mobility as service space, but at least we just put in 3 names. You can speak about Yulu. I think you were closely, or I think at least you're in this space, right, for some time.
Yeah, the Yulu is one of the mobility service provider, which is basically being predominantly used by a lot of the people for short distance commuting. So micro mobility is something which is being done by Yulu, where the vehicles are actually left on road. Or specific stations, you do stations where you can pick them up, go to and be only charged for the amount of kilometers, number of kilometers that you travel, and it's all green mobility. So the overall cost economics are also in favor. But having said that, yes, so people have to be also conscious about the assets not being misused or broken on the road. So that's one of the problems that I can see as a mobility as a service. At the same time, while it provides a lot of flexibility for people not to own a vehicle and still be in position to use the vehicle, only pay for the number of kilometers they use rather than owning it. But at the same time, there is a lot of vandalism that happens in the mobility as a service also, which is unfortunate.
I agree. So these are some cons, and I think some discipline as an individual should.
Yeah. Hello. Are you able to hear me?
Yes, you're audible, Alok. Yeah.
Okay, I think we lost Pramod in between. Pramod, are you able to hear us?
Yeah, I can, but
Okay,
I don't see the next slide coming up.
Yeah.
Right. So while we are speaking about connectivity and connected mobility in particular, I think most of them would have been hearing about V2X and V2I, V2P. This picture speaks a lot, right? So when there is everything that is connected. We will have the vehicles connected to the traffic signals. Then we have to the networks. We will have to leverage the networks which we have, and not we will have to. We are already leveraging that, and that is called vehicle to network. And also we are talking about vehicle to pedestrians. So pedestrians can also be alerted, and even pedestrians has a chance to speak to the vehicles and through their networks. We are doing this. We are today, if you look at the aggregator business, it is pedestrian to network, and then there is, you can go and get any taxi which is coming very quickly, right? And most of the important features which you see is the vehicle to vehicle. We speak a lot about these. And to go to the next slide, please.
Yeah, just one particular point I wanted to highlight. I think the vehicle to P, V2P, vulnerable use cases scenarios, like, somebody who is, handicapped, or somebody who's blind. So EVs, electric vehicles, example, for that matter, don't make noise, or for that matter, the new generation cars are also pretty silent. So having some of these tech allows some of the gifted or disabled people can also be able to be visible to these users, and also have the vehicles visible to these guys using some of the devices, smart devices, maybe a smartwatch or a smartphone or things like that.
Right, that's a good point. Yeah, definitely they have sensors, if you see, are the crucial part of this ecosystem. Connected mobility. So a vehicle can identify what kind of pedestrian is in front of them, and it can make a predictive analysis and also prescribe whether to brake or whether to slow down. This is definitely a known application which is definitely coming up. And yeah, so this is something which we spoke. I jump on this slide.
Yeah, so
maybe you can go to the next slide.
Yeah.
Right.
So what do you think? Why do we want, the vehicles to talk to each other on the road? It's not just about making a car as a connected medium, but we also want the vehicles to talk to each other. And it's kind of obviously, when we look at the overall use case scenario for the technology, it's like as good as humans looking at each other and having that telepathy, or the visual indication and things like that. But it's more than that. The sensors are also interacting with the cars. One of the key things which we will be talking about upcoming in the slide is the ADAS or the radar systems and things like that which are required. But not just at an independent car level, but all these systems also need to, since we expect a lot of these cars to coexist together, better the interaction between the vehicles together would enable a much more robust and a secure way of the autonomous enabling the autonomous cars, or for that matter the overall public and road safety kind of a thing. So I think it will be more better explained with the help of a video, which is over here on the next slide, which is platooning. So I was actually very, very impressed with this kind of a technology, where just to kind of summarize, the idea is that for an autonomous vehicle, instead of making all the vehicles as autonomous, there is going to be a leader and there are going to be followers. So it's kind of a wolf pack, you can say. So one of the wolf is the leader, and then rest of them are follower. So exactly same technology can be implemented, where the followers are basically following the leader, and the leader truck basically guides the way out.
I'm not sure if others are. I'm not hearing the sound.
So I don't know how to share the sound. Is there a way to share the sound? Share sound. Yes, there is a share sound. Okay, so let me just play that again. Let me know if you can hear.
Yes, Alok, we are able to hear.
When we first began around 2010 driving with the platooning, we only drove with longitudinal control, and today we have a technique that allows us to even let go of the steering wheel and let the truck steer by itself.
I was driving as the third or the fourth truck, and it was a great experience. It was very relaxing, giving control to the system, being able to follow 4 vehicles in a platoon without having to do anything.
The intruding vehicle, it's as with today, we're driving with very close distances. We are about 10, 12 meters between the vehicles, so it's very narrow for intruding vehicles to cut in.
Now I'm doing the cut in, and I have a track behind me with a distance of 2 meters. And now the gap between me and the track behind should enlarge to roughly 10 meters. And then when I'm moving out again, the track should accelerate a little, so the gap is 10 meters again. Now I'm doing a new cut in, but everything is calm and it went out well.
What we also did was a brake test, so the lead vehicle initiates a full brake, and my vehicle at the same time reacted and braked down to a full stop. And the vehicle reacts faster than I would have done.
I would like to see pilot test on the road within 3 years' time.
So isn't it impressive, Pramod, the way the connected car, the right example of the connected, the vehicles talking to each other?
Yeah, see, these are the advantages. See, we as humans, we are susceptible to make errors, and technology like these will definitely make it to reduce those errors, and that's the main purpose of it. And yeah, that was a fantastic application by Volvo. And today, even you see our own OEMs, Indian-made OEMs, Tata Motors, they are launching accident controls sensors. We saw some ads which is coming up. Most of them would have had a chance to look at it. While we speak about such kind of accident prevention and platooning, there is a lot more applications. Infotainment, we have vehicle-related parking system, park assist, traffic assist, and road hazard warning. Today we miss, right? Today what we tend to or ignore, because I said humans are susceptible to making errors, or they tend to make errors. We don't see signboards, hazard boards, but today with these sensors, they are definitely watching everything and anything. And it brings a lot more ease, and at least to avoid a lot more accidents. Autonomous driving, high definition maps are going to get really too good. They are going to get so nice that you could actually map even the dividers or the path or path in between. Even those paint marks are being mapped. And remote controls, you can actually, right from the time when you move out from your home to office, if you're in colder countries, you can actually set your car to a warm phase, or even when you're in hotter countries, when you're in northern part of India or even southern part of India where there is extreme higher temperatures, you can cool it down before you get in. Emergency today, emergency e-call, crash infos, just with a single touch of a button, there is messages going to the nearest police stations, medical health cares, medical centers, and also to your close family. And remote monitoring software updates. You don't have to drive every time the car to go to the garage and get it checked. The AIs and the upgrades can be done remotely. And then not only just software upgrades, it will also assist you to when is the vehicle due for service. So you have a plethora of applications, and not everything will come all together. India markets are more sensitive to the commercials. So slowly now they're getting in there, and days will come sooner or later that we will have a complete set of applications inside a mobility space. Next slide. So here you see how much in terms of percentage we are talking about connected cars today, right? From fuel tracking, entertainment, access, the maintenance part, which I was just speaking in I was just a little bit ahead. I wanted to speak on this slide. And most of us today, when we are using, right, we are doing fuel tracking in terms of electric vehicles, looking at the SOC. It will also give a kind of sense that how long can you drive even when there is less SOC left over, and that range anxiety can be brought down. And this can be done through connected mobility. It will take over and also help you to say what must be your driving pattern, such that you will go to the destination without having the car being stalled. And who are doing all these sensors? You see on the right side, what kind of sensors? Radar, LiDAR, the fisheye camera is there. And then you have, when you're talking to a voice control assist, so how will it recognize who is actually commanding the signal? So these are a lot more sensors today, which is being placed inside the car. It can able to detect which is the command voice and which is actually another noise. And these are fantastically done by the sensors inside. And you could go to level 4, level 5 automated vehicles. I think there is a slide ahead which speaks about different levels of ADAS which we could speak about.
But then one question. So do you think that having so many sensors on the car would also lead to a more maintenance of the period of time?
Not maintenance, at least this is the first cost, but I would say investing in such kind of sensors, reliable sensors, OEMs are passing on those credit to the consumer in terms of having a comfort drive, safe drive also. I would like to add on. So if you today sit in the cars, you would observe that there is very much less noise which is there. It's just not by the mechanical design, the technology of those sensors, which is actually cutting down the outside noise by giving a reverse signal to it. So there is a Bose and another sensing organization who actually are passing on these applications. Yeah, to an extent, maintenance in the sense they are more reliable, otherwise sensors will not be used. But it brings, because consumers have to pay, this I agree, but they are a lot more reliable. I think it could be a lot of maintenance free. Might be that one of the cases you could find a sensor at fault, but you will have almost maintenance free sensors.
Right. And it can also detect the squirrel who is sitting on the top of the roof.
There are only squirrels on the top of the roof, dogs underneath your cars. Everything can be done, which we generally tend to make a mistake.
Yes. Okay. So, yeah.
Yeah, this is also another super ad. Just run the video, please.
What makes us human? Sometimes it feels like we've forgotten. Maybe we can learn again from someone who's been learning from us.
Welcome, Benedict.
Learn to recognize each other. Hello, MG. Turn on AC.
Turning on AC.
Learn to listen and respond to each other. Hello, MG. Play my favorite music.
Playing your favorite music.
Learning to learn about each other. Say hello to the family, Hector. Open sunroof. Very obliging. Thanks, Hector. That was fun. It's a human thing. What makes...
Yeah, that sums it up. And when we see such kind of comfort, and then you have more or less the data going outside the car and coming inside the car, what we already see is some kind of threats with connected mobility also. I think you can go to the next slide.
Yeah, exactly. So while I was very intrigued by the technology of voice integration, but at the same time, one of the things which I feel strongly where the cybersecurity has to play a lot of big role, or for that matter, overall security systems have to be kind of very heavily encrypted, which does not allow the untoward incidents. Like, example is one of them, carjacking made easy. Hackers create a device that can unlock any luxury car. So basically, one of the examples on the bottom right is something similar to it, that using a third device, you can actually make the car believe that it's your car, and the device can actually be located about 100 yards away. So basically, it's kind of a cheat device to allow the car to feel that it's the actually key fob, and the person can just get inside the car and then walk away. So that's also one of the things that, while the technology is helping, but at the same time, even the hackers or the car thieves are getting smarter and smarter using of some of these technologies. So always one of the downsides. Another thing which I feel is, is big problem, even though it's not directly related to the connected cars, but I'll just take a moment to talk about this small device, which is the Apple AirTags, which is actually creating a havoc in lives of a lot of people. It's a small device, the size of the coin, which can be stored anywhere, and it uses the Bluetooth Bluetooth of different phones to exactly locate the respective device. And such has been the repercussions of, or the downsides of such technology, is that there have been so many people who have actually faced harsh realities of having so much of connected thing, that they are being stalked. Women are being stalked in US. So there is a class action lawsuit that is going on in US, where people are finding it dangerously prohibitive to their privacy and security, because women are being stalked or the children are being stalked. I'm like, somebody can just sneak in the small device inside your bag, and they will be able to locate you wherever you are, because it's just going to use the Bluetooth from the different phones to send the location of the device or the AirTag. So the idea is it becomes dangerous for people. So why I give this example specifically is that, just by using a small transmitter-based device, it's causing a threat to the security and privacy and security. Imagine that what happens in a connected car, that when you are using the vehicle and it's basically the voice-based systems are hacked, and a third party can actually hear to the conversations of the private conversations that you're having in the car. So there is obviously a downside, but I foresee that, I think we as engineers, it's a responsibility to kind of come up with the encryption solutions which can avoid getting into the phase where these technology, instead of becoming helpful, ends up becoming more counterproductive to all of us.
Yeah, on a lighter note, to all our listeners, just be very careful on clicking I agree.
Yeah. Sure.
Right. So how, and when we are talking about this kind of threats, but still we continue to focus with our autonomous drive assist system sensors, which I've been talking about right from the first slide. You have different kind of sensors which we'll have to consider while designing connected mobility or ADAS. So short range radars for park assists. So today we all know that we use an ultrasonic based of technology. Then medium range radar, rear collision warning, and also adaptive cruise control, long range radars. Today, Tata Motors, when they've launched it onto their trucks, when a driver is looking at his home and talking about the mangoes, there comes a trailer, and then he actually forgets to brake, but then technology comes to his rescue. So sensors are definitely the most crucial part in this ecosystem. And then you can blind spot detection. We know we have several blind spots. Then also even the cross traffic alert, where most of the accidents happen because we don't get to see them, or we don't have the reflex to go and put our brakings. But sensors are there to support us, assist us to avoid these accidents. So these are the advantages which we have. And radar is radioactive detection range is coming helpful to us. Next slide, please. So here you see it gives you an overview of what kind of assistance which we will get from the ADAS systems through sensors, and even lane departure warning system. When we are in a lane, sometimes when we are looking forward, we tend to forget to look at the rearview mirror and take a right turn, but someone from behind, there might be all possibilities of an accident, and which we all know there is a probability to happen. So such kind of sensors are going to be installed. And then the application is the lane departure warning system. It gives you an alert that whether you could really turn. the traffic sign recognition system, night vision, and pedestrian detection. Sometimes there is fog, and even just not fog. With this applications of connected mobility, even elderly people who can actually go take out their vehicles with confidence. And that's the assistance which we get out of such kind of technology.
So yeah, so while you spoke about this, I was actually thinking that, you know, one of the trivia is that Tesla does not use lidars or radars and things like that. So it's Elon Musk is has always been advocating that the radar-based systems or the lidar-based systems are expensive, and that basically brings up the cost higher. So what Tesla has been doing is using the vision-based system for the overall autonomous cars and, you know, some of these autonomous driving and things like that. So such is this situation that, you know, they basically use the triangulation-based techniques where the measurements are based in physics and not like radar, basically. And what it basically does is that, first of all, the cameras are much more cheaper than the radars or the lidars. And you can install multiple of them, and you can continue to kind of have a vision-based system to improve it with the help of the machine learning, because as you drive more and more, there is more data which is getting collected, and that can be analyzed for improving the vision-based systems. So it's very interesting, but at the same time, there are some you were saying something, Pramod?
No, go ahead. When you said LiDAR, they don't use, for sure today, there are multiple sensors. I think every sensor, LiDAR, radar, or even the cameras have their own pros and cons. But considering to have a very efficient autonomous drive assist system, we will see all kind of sensors coming up. And all these sensors talk to each other through the vehicle control unit, and you have a safe driving ahead.
That's right. So one other thing which we will talk about, that, you know, while we are talking about the autonomous system, we should also be cognizant of the fact with the great technology comes great responsibility as well. You know, we often keep seeing news in the media that some Tesla driver has actually put the vehicle on autopilot and has you know, dozed off and things like that. People are playing you know, they're on phone calls, or they're sleeping, taking a nap. In fact, very recently, what happened in Germany is that a Tesla driver fell asleep on Autobahn, and the cop cars were actually chasing the Tesla, and Tesla was not ready to stop. And they were trying to kind of honk a lot, but since it's being an insulated cabin, so the driver was not able to hear to the honking, and the Tesla was not ready to stop. So they realized that there was a cheat device which was installed on the footwell, where the Tesla was made to believe that the driver is still driving, putting his arm onto the steering wheel, and the leg is on the accelerator pedal. So such kind of things happen. And very recently, I came across some nuisance also being done on the XUV700, the car, one of the car which has got the ADAS level 2. So you can see some of the people are actually playing Ludo while the vehicle is driving itself, which is kind of very, very problematic situation, because if people start misusing the technology, so it becomes a safety hazard for other people on the road, because these guys are like, you know, doing it for the fun, or maybe they might be wanting to get some likes or dislikes or whatever, but it's kind of putting others' life on stake. So let's not consider the road as a track, because there are other users on the road as well who may not be having such tech-laden cars.
But one word which you mentioned, I want everyone to register, that technology has to be handled with a certain responsibility. And yeah, you will have to use this wisely. And on the right side, which you say, okay, I can say that there is technology-wise, the car is bound to be driven like that. But this is absurd. Yeah, this is way beyond irresponsible driving.
Yes.
Yeah, again, I come back to sensors. Sensors is something which I love to speak on. And you see this kind of sensing will prevent certain accidents, optimized airbag deployment, the drowsiness alert. And today for Indian applications, this is going to save a lot of life. And today our drivers who are on the commercial part, who are delivering a lot of goods, they are so much stressed up. And it's not that no accidents are caused by intention. It's caused by fatigue. It's caused by very less from a vehicle failure, mostly from a fatigue point of view. So here, the technology comes in favor, right? We got to assist those drivers to give them a warning that you are tired, you are not in a mood or in a way form to drive a vehicle, or at least to stop an accident. So drowsiness alerts is something which is going to very fast come up in on the Indian roads and save a lot of lives. And even the airbag deployment. So, the airbag deployment should happen at the right moment when it is supposed to happen. So, and the ADAS sensors are going to assist such kind of deployments and applications. When we are talking about, this is the adaptive cruise control, one of the best examples of from an ADAS system, and this could be categorized as level 2 or level 3, which we'll see in the subsequent slide. So this principally works with a sensor, a radar sensor, and then there is a distance being set for the vehicle to take control of. And in the ADAS language, or when we're talking about the functional safety, the latency plays a role. So when we write software, when the codes have been written, when should this functionality come to a stop? So this is already predefined. And under all circumstances, if the distance is going to go low and there are multiple sensors to vouch for some kind of warnings, and definitely the adaptive cruise control will come out. This is one part, right? It saves accident. The second part is in traffic, where most of our vehicles are polluting the environment because we are unnecessarily putting up acceleration even when it's moving very slowly. So cruise control can also work in traffic and then minimize unnecessary usage of the combustion engine. Also, this can be possible in combustion engine, not only in electric vehicles. And these are the benefits which we are going to see through connected mobility. And the level which I was mentioning in the previous slide, this is a regulation which says what levels of autonomous vehicles we are going to be in. So you see from level 0 to level 5, level 0 is what we are having. Actually, you don't have any sensors. You are completely depending on, it's completely driver dependent. But then level 1 and level 2, you see examples in the bottom rows. We're talking about lane centering to keep in the same lane, adaptive cruise control, which you saw in the previous slide. And then you could also go to level 3, 4, 5, where the humans will be replaced, but not completely. There are warning signals or at least alerts being given to driver when he has to take care. And the last level 5 is something that you don't have a driver at all. So if we forecast when and where we could see these levels, India could see us soon be, okay, we have level 2, level 3 is also going to come up because we have great roads infrastructure, which has been accelerated by the government of India. We can use on those roads, you could see level 3 and level 4 coming up.
So while we are I was understanding on some of the technologies and the level distinguishing between the different levels of autonomy. So let's watch one of the video, which is from about 3 years back. Of course, the systems have become much more sophisticated, but here is one of the video where a Tesla is in autopilot mode, where the sensors were not really able to understand that there is a truck that is lying on the middle of the road, and Tesla basically went and just crashed into the truck without realizing that there can be an obstruction. So of course the technology has matured, but why we are basically trying to tell is that the technology has to be used very cautiously. So you will see that over here a Tesla is coming in the same lane, and it just kind of goes and crashes into the truck which is lying on the street, on the road. So it kind of shows that yes, the different levels of autonomy are there, but at the same time, the systems are still getting mature. This is from 3-year-old. This happened in Taiwan, and you can see that from the another angle as well. So how it happens. So interesting thing is that you will see the Tesla actually realizing the obstacle and braking just at the last moment, but the momentum was such that it just went and crashed into the truck.
Yeah, I think these are definitely some lessons learned, and then those could be it in a very, I wouldn't say as a nascent phase, but even a premature phase. And now with such kind of accidents, which is happening, see, it happens, and then so are we learning those kind of lessons, which is in 2023 years down the line. You don't see some kind of accidents. Yeah, technology comes with some risks, but then we got to do a lot of testing, and all the software engineers and the OEMs at their side are very, very cautious even before launching it, because it's a reputation to the brands, and then it's a risk to the complete industry itself.
And I think it's also heavily regulated because the government actually decides the level of autonomy. There has been a lot of questions which have been raised. You know, the idea is that a lot of in US also there has been a lot of questions that have been raised on the autonomy of the full self-drive of Teslas and things like that. But I think overall, as we go further, the regulations are also going to ensure that the companies, the car companies, are actually not misleading they're taking safety very seriously, in short.
Agree. Safety is the primary function, is necessary. At the same time, nothing afterwards. In parallel, safety has to be, and then there is a functional safety called ISO 26262, which actually defines that how much thinking should go and what kind of latent failures or single point failure metrics is going to come. And there are also, we have sort of safety of the intended function, and because since you mentioned about safety, that is definitely regulated, and everyone even before launch is quite responsible to be sure that there must be no failure. And when we are talking about such kind of data, the milliseconds, we need a infrastructure also, right? And we today, that's one of the reasons we quickly moved from 3G to a 5G within span of about 10 years. And today we already have 5G. So look at the speed. It's a phenomenal jump. And we were okay with 4G, which was 100 Mbps. And then we are today at 5G, which is 100 times more, right? So there is, this infrastructure is a must. And this will be quicker, efficient, without any latency of data to be transferred between the V to I's, V to V, and any machines, objects, and device with such kind of infrastructure will be much more safer. It's not to say that 4G is not safe, but the implementation levels will be not quicker. With 5G implemented across the nations, across the globe quickly, so they move ahead with launching level 4, level 5. So we are coming there today. 5G has been in an experimental phase slightly to the mobiles, and then it goes to our appliances through voice assist systems, and then finally it will roll over to the vehicles. And even when we are talking about service-based predictive maintenance, it is happening through such infrastructure.
In fact, I think the amount of transaction of the data that would be happening will exponentially increase as we have more and more connected cars on road. And I think that's where the speed becomes more important, because so much of load on the infrastructure with the 4G will become a 3G or a 2G. So a 5G with so many people on road and connected cars. So the 5G will essentially work like a 4G. I'm not on a lighter note, but yes, the idea is that yes, there is going to be a huge amount of data transactions that would be happening for enabling the connected car solutions.
Right. At the moment, a lot of data has been collected and analyzed of how this would really favor, and then what could be some kind of downside to it as well. So with connected mobility, we see a lot of benefits. Optimized transmission control module in signals. At the end, we are all working towards having lower emissions from vehicles, automated driving, reducing accidents, reducing congestion is also reducing pollutions. Quality of travel enhances. You can do multiple tasks without losing your focus on the roads. Ownership experience, you have a proud feeling that you can do a lot of things in the car. Improved resource utilization, fleet management, as you were mentioning, Alok, reduced accidents. And while we speak, this also brings new avenues for businesses. So you did really catch that point that there are a lot of sensors coming in. So sensors will be in demand, and not only just to supply sensors, quality sensors, and demand for embedded system development will continue, because each of these modules will have its own control units and more employment generation. So connected mobility actually will shape up a good employment opportunity. While we speak some benefits, there are also challenges. You did mention about privacy and spectrum. We just spoke about this availability of infrastructure. It is just localized to the central urban districts. Protocols, the way this has to be communicated, how we can use a standard code, not to make our own codes. Cyber security. This comes with a challenge. There will be another function vertical which is soon coming or has already started, and all this comes at a certain cost. But however, even 25% buyers still are okay to bear that cost, because it's a nice feature to have, right? It's not a must though, but it's a nice feature, but they enjoy, and we have 25% of the crowd who is raising their thumbs up for connected mobility.
I think the newer generation is basically more towards the technology surrounded by technology. My daughter likes she often asks me that why we don't have a touchscreen in our car. So because the new generation is born around the touchscreens and the soft touches and things like that. So, and the voice commands and things like that. So I think they would want to see, we are going to see a lot of these technology getting more and more into our devices and cars and things like that.
Yeah.
One particular challenge, I think somewhere we need to also be there, that the hardware obsolescence, which will lead to not functioning of some of these systems. Example I'll tell you is that the first is no longer usable in cities, because for that matter anywhere, because it was based on a 3G network, and you just cannot change the SIM card and things like that, because it has been designed with a 3G SIM. So since 3G networks are no longer available for most part of the country, so the vehicle cannot latch onto any network and the connected solution is gone. So we probably will have to also be aware about that when engineers build systems. So there has to be some way to upgrade the advanced mobile networks, communication networks, which can be embedded without having the consumer to shell out a whole lot of money. Because in case of Ather, somebody will have to change the entire display and the ECU to do that, to 4G or 5G and things like that. So as the technology matures, the obsolescence will also reach much more faster. Today we have 5G. 3-5 years down the line we'll be having 6G, and then 7G or 10G. So a car which is being bought right now may be having a 5G connectivity, but 5 years, 7 years down the line would be obsolete.
Right.
So those things also have to be kind of, I see them as a challenge.
Yeah, and then we have eSIM cards, which is coming up. Yeah.
No, but then it will not be a 6G capable. eSIMs are just a provision to avoid having a hardware SIM card.
Yeah, just keeping in time constraint, I think we are a little stretching. Sorry, guys, we just quickly move on this. While we know networks could be a threat or even challenge, there is one kind of communication equipment called dedicated short-range communication. So this doesn't need a network. This is just a device which will be inside every vehicle. So it is like our wireless phone calls which you see every cop is talking about, right? This cops can speak with that wireless on that similar principle. We have dedicated short range communications which can be used on the vehicles. There is a lot more benefits using these, and then they will have their own spectrum allocation of how this can be communicated. So Alok, if you go to the next slide, please. We have collision warning applications. You'll see a lot on this picture. It can be at the intersection movement, which is exactly in that blue box inside. Indication assist when you're turning left or right, and even also while overtaking, right? This would forward collision warning. All this, instead of depending on the networks, this can be much more quicker and efficient by using DSRC. And this is also another part of connected mobility. But then there is a question of, because this brings in a certain cost, right? If you go to the next slide. So here you see the benefit when we move from a cellular based V2X to a dedicated short range communication. The distance to stop or driver reaction plus the braking distance is phenomenally very low in a DSRC. So at when he's traveling at a certain speed, the stopping distance is very small in terms of a DSRC, whereas in a cellular based V2X, where network where it's dependent on, it takes a little while longer. Of course, relatively better than when there is no sensors today, but between the technologies there is competition, and whether it is normal road or IC road, these kind of technologies will help us prevent a lot more accidents. Yeah, here you see a lot of applications. I don't want to really read through every line. I'm sure this kind of content will reach out to all the participants. I will move on to the next slide, please. That's slowly coming up. So just to sum it up, right? So we are talking about connected mobility. You will be hearing connected mobility, connected cars, autonomous drive assist. Then you have safety, electrified, as well as shared. So you can hear it in different acronyms, cases, ACE, everything. And we will also use electric as the momentum now, fuel cells, hydrogen, which you are hearing for sure, telematics, cloud, the usage and the purpose driven, driver assistance. With all these, we need with comfort, there is a functional safety. Means with connected mobility, there is a software, and the functional safety of that software coming into activation. This is definitely been followed. There is an ISO 26262 is another beautiful subject. Cyber security, there is threats when we are exchanging data to the internet, and then safety of the intended function. We cannot ignore and say, okay, we did not test it in wet condition, we did not test it in altitude, we did not test it in cold. There is nothing that has to be a reason for an accident. And engineers are working very, very cautiously and very focused to do a lot of tests before it has been launched. And then these are the regulations: functional safety, cyber security, safety of the intended function. It's regulated, and then there is engineers following this one. Yeah, so we are coming at the end of the session. So we at Device and Ganiki, this is our expertise of areas: electric vehicle technology, future mobility overview, ADAS, automotive electronics, IoT, cyber security, and a quick summary of who we are. Device is based out of Pune. We are driving new technology paradigm through skill development and partnering with OEMs for digital transformation. And of course, we are a part of, means we are definitely supporting ASDC whenever there is a need arising. And what you see is also Ganiki. Ganiki is our subsidiary. undertakes specialized and customized research in the areas of future mobility. So device is more technology oriented, supporting with services, and Gyaniki does the trainings and then specialized reports. We have about 7,000 plus training hours and a lot more OEMs and customers for us who are adding value to us and the environment. Alok, it's over to you, Alok.
Yeah, we are also one of the customers of device. So Quargos is in stealth mode. There is no information that is available on the internet as of now because the kind of product that we are working on demands a lot of secrecy of development. As we explained it, like, we are advancing the world's transition to smart and sustainable logistics. We are working on product which is predominantly used for the commercial applications. It's a two-wheeler platform which is being developed from ground up. And here is what is the problem statement that we are, trying to challenge, work around, that we are building business which revolves around the society and habits. In all the 5 cases that you see on the screen, in all 5 cases, you can see that the two-wheeler is being modified, or there is some kind of a jugaad that has been done to make use of whatever work that the respective person wanting to do, whether it be local milkman that we all of us have seen while growing up, that he's using some kind of a jugaad or some kind of attachments and fitment, or a roadside assistance guy is using some modifications on their bike, or a leashes guy carrying a heavy backpack, an e-commerce guy carrying a backpack and fire bike. So a lot of times what we may be a lot of people, as I've seen, that they would be only thinking about delivery boys, but the larger reality is when you try to look at it, even a local grocery guy, or somebody who is working as a sales and marketing executive, or an urban club guy, everybody is using some form of a two-wheeler by doing some modifications. So, which they don't understand that there are loading limitations, because these vehicles were predominantly designed for carrying humans and not cargo. So there is a loading limitation, there is a physics of loading and hamper dynamics, and which slows down the overall operations. And overall, it's not scalable. I mean, like, as simple as that, Tata Ace was built around the carrying the load, and it was not built around only one platform. So the differentiation is like, you can modify the Tata Ace to be used as a van, you can modify the Tata Ace to be used as a milk van, or any luggage carrying transportation. So that's one good example that we can say that. So we are building a Tata Ace on 2 wheels. So society and habits, volume and weight, hail jugaad. So this is what you predominantly see. We went to 6 countries and 15 Indian cities to really understand the usage pattern of two-wheelers, and we found that everybody is just trying to do the things on their own way, and nobody has one unified solution which can't possibly be used for this one. At this stage, I can only talk about and disclose this much, but very soon you will be seeing Quargos brand. You probably will see some of the vehicles being tested on road, and I'm sure I can guarantee you that it is nothing that has ever been seen anywhere in the world.
All the best, Alok, for sure. It looks very interesting.
And we are powered, Device and Quargos are working together to enable this.
It's proud to work with you.
Questions?
Yeah, time for the weekend then.
Yeah. Team, do you have any questions? Yep. Thank you, Alok and Pramodji, for your valuable session. It was very informative and interactive too. Thank you very much for your time and presentation. Thank you.
Thank you very much for time and space.
Thank you, Pramod.
Thank you, Alok.
Thank you, ASDC. Thank you.
Yep. Thank you very much.
Good evening, everyone. I would like to thank you all for attending this informative and engaging webinar. Special thanks to all our speakers, Mr. Arindam Lahiri, Chief Executive Officer, ASDC.
Thank you, Mr. Arindam. Alok, are you online or did I lose connectivity?
No, I am online. I can hear you very well.
Okay, but we don't hear from the other side, right?
I think I'm not able to hear Karthik.
Yeah. We have a very mute presentation. Huh? Karthik?
Yeah, am I audible? Hello.
Yeah, now we lost you for almost a minute.
Almost for a minute. Okay, okay, not an issue. Yeah. Good evening, all. I would like to thank you all for attending this informative and engaging webinar. Special thanks to all our speakers. Okay, so I hope I got interrupted in the middle. So am I audible now?
Yes, yes, Karthik.
Yeah. Thank you for your time. Thank you all.
Thank you very much, and thank you, Alok. Have a nice evening.
Alok and Pramod, I have one question. Can I ask you?
Yes, please.
See, you guys only providing training for the corporates, or are you really implementing any use cases like platooning and all you demonstrated now? You presented now.
Yeah.
Are you implementing any use cases actually?
Training, see if I can take that question, Alok. From the training perspective, we are doing trainings across corporates, across institutions, and you can also look at our portals if you want data on ganiki.com. And coming on to the used cases from a vehicle control unit and data loggers we have working around with. And platooning is not that which we are really doing. Platooning was just a case study for today's presentation.
At Qorvos, we are doing connected vehicles, but not platooning. We definitely foresee that in future, when we get to work on the four-wheeler platform, we probably will be more leveraging that. But yes, connected vehicle is something that we are already working on.
Okay. See, I have one more question actually. Whether you are supporting any of the security related, cyber security related implementation for the connected and autonomous related platforms?
Yes, we at Device are working on it, sir.
Okay. So far achieved anything? Any project is achieved so far?
Maybe we are in we are in the concept proof of concept stage, and soon we should get to the next phase. Might be we can have your contact numbers, and then we can walk you through that, and then we will see where we can engage with the projects.
Okay. And one more thing, you see, suppose in autonomous platforms now, ROS2 DDS based as only that platforms only. Currently, they are available. Whoever you take an example of Autoware or Apollo, they are all these autonomous applications are developed based on the DDS or ROS2 framework only. Do you guys have any idea about adaptive AUTOSAR kind of architecture and implementing these ADAS applications or TAD applications?
Yeah, today from the four-wheeler application, we are getting there. At Device, we are focusing on two-wheelers at the moment, but we have our VCU for the four-wheeler. And in this year, by fourth quarter, we would want to evaluate using adaptive AUTOSAR to it. So might be we have a chance to make some discussions and work with you for any of the future projects. Again, this is in the proof of concept stage. So both AUTOSAR and cybersecurity is something that we have been using in our products.
Okay. Because I'm not hearing anybody is working on adaptive AUTOSAR actually. Maybe it is an initial stage. I really, I just want to know, who is working on it actually. Maybe the R&D they are doing Bosch and Continental and Elektrobit.
Yeah, see, Bosch is definitely there and using AUTOSAR not from now, since I've been working, my earlier company was Bosch.
Yeah, but not adaptive actually. They adaptive level applications they couldn't achieve so far. I mean, no one has achieved so far. The basic AUTOSAR, it is okay for the ECUs. It's okay. Yeah. That's all, Pramod, actually. But actually, I'm looking for the adaptive AUTOSAR related implementation for the ADAS applications, whether anybody has done it actually.
No, we can help you out over there and get you the right to the right place where you can have some use cases who have been working around. But I know there are people working, a few of them which I've heard of. Maybe we can connect post this training session and or maybe after this tech session. Mr. Ramu or Karthik, you have Mr. Ramu's contact. You can please pass it on. I will.
Sure, Pramod. Yeah, definitely I will do. Yeah. Yeah.
Thank you, Pramod, Karthik, and Alok.
Yeah. Thanks
a lot.
Yeah. Thank you all. Thank you for joining this session. Thank you.
Thank you very much. And
thank you.
Thank you, Alok.
Thank you, Pramod.
Thank you, everyone.
Thank you. Happy weekend.